I just realized that we had not, I had the recording paused on that. My apologies there. So we missed that little bit of discussion. But all right, so I'm going to make that file available. And now I need to actually figure out, I think if I go to chat. So if I do this, let me see. Data sets, and that was called deed processing from class. So CD. Some survey class materials, data sets, and deed processing from class. Okay, so everybody should have gotten that in your chat window, and you should be able to just click it and open it. Everybody get that okay?
Yes.
Says you don't have, says you don't have permission to save this file. Contact the administrator to obtain permission.
Oh, good heavens. That's an issue on your system. Are you able to open it at all, or you're just trying to click it?
Whenever I clicked it to like download it,
Yeah.
and then I click save, so then I go into Carlson. It says that.
All right, so you click it and you have it open on the screen, and then you're trying to save it. Try a file save as, and then see if you can put it in your local folder. You know, which is where you've got all of your data files now. I mean, first of all, Zoe, are you able to open it? Can you see it when you have it on your screen?
Yes, like the file.
Yeah, and if you just click on the one in the chat window, does it open it up inside Carlson? So you can see the lines and such.
No.
What happens when you just click it?
Whenever I click on it, it says, how do you want to open this file? And it just goes to like apps that I have on the computer. And Carlson's not one of the apps.
Well, it would be, but it's called, what's it called? Serve. Hold on a second. You'll have to navigate to it, and it is called. It's called scj start.exe, but if we go to that, so it should be in your program. Oh gosh, it's buried. It's down in all right, is one of your apps. First of all, I want to ask you how you want to open it. What are your choices?
It gives me Microsoft, and then it gives me
You should see either an IntelliCAD or.
yeah, no, it does not give me those. Just trying to.
All right, let's do this. I'm going to, I'm going to stop my screen share. I'm going to let you stop it, and then I'm going to ask for control, and we'll see
Okay.
what we can do there. So if you'll share your screen.
1 second.
All right. And now you'll have to give me permission on that. So now get to, show me then where it comes in to, let's see, let me,
Well, now it's doing this.
okay, good. Now, so do you want to open or save? So if you choose this pull down here, you do a save as. Okay, and now let's put it instead of downloads. That's where it's blocking your permission. You should, where are your,
Scroll up.
where's your data files? Are they,
It's in data sets
it's right here, right there?
and then data sets again.
And then data sets inside of that. And yeah, deep processing from class right there, it is. So if we save that, we'll replace that just to, and we'll close it. Now, let's go here and open that deep processing from class. There we
Awesome.
go.
Thank
Okay, you bet. All right, so I'm going to stop remote control and I'll stop your share. I'll go back to my share. And I'll close the chat. And now we should all be at this point, correct?
Yep.
That's good. All right. So what we'll do now is if you select that drawn figure, which is just a polyline, but it was drawn from the deed description. And you saw as we zoomed in here really tight, you know, it doesn't quite close. There's a little bit, that's our deed misclosure right there, that amount of difference. Okay. So, but what I want to do is to take that figure and I want to just copy it off to the side of someplace. So I'm going to select it and then I'm going to choose right click copy or go to edit copy or use the toolbar, however you want to do it, and just drag a copy of it out to the side somewhere. And then I'm going to take that copy. I'll select it again. I'll hit escape to clear everything. I'll just select this copy. I'm going to come up here and change its layer, or I'm sorry, change its color so we can tell that we're working on the copy. And I'm going to select it so that I see the grips, and I'm going to come in here and rearrange this into a single point. In fact, I'll do that by, say, bringing this guy down to right in there, and then I'm just clicking and dragging and letting it snap point to point. So now it's all on that same single point. So that's been eliminated as 2 points. Although there are still 2 vertices there, but we'll just put one of them at the same place as the other one. And then I'd like you to go to, say, this corner over here. And let's just move that a little bit. I'm going to, let's do it this way so we can control how much we move it. If I select that figure and I'm looking at my properties, which is in this panel on the left, if you don't see that, right click the mouse and choose properties and it will bring this up. And down here below in the geometry portion, you'll see vertex 1. And as I click and move around the figure, you'll see a little marker change. And as you see, from 1, it goes all the way around to there's 6 and then 7, which is exactly the same as 1. If I click it, you see it just moved back on the same thing. So we're going to change a couple of these. I'm going to go up there. I'll leave that one alone. I'm going to click around to this vertex 3, and I'm going to just click in here, and I'm going to change the X location. Instead of 5621.13, I'm going to make that just 5621.5 in the X, and I'm going to make this 5014.25 in the Y. Okay. Then I'm going to click back up here where it says vertex 3. I'm going to go to the 4th spot, maybe leave that one alone, but I'll come down to this one, and I'm going to make that one say 5423 in the X and 4765.
So since we have like ours in different spots than yours, if we change it to what you have, it's going to be
Oh,
complete.
no, I'm sorry. Gosh. Yeah, because you didn't get the copy. You copied to a different place. Just tweak them a little bit, but I don't want to tweak them like 10 feet. I just want to, change their position by, a couple of tenths or maybe even a foot here or something like that. Maybe not quite a foot. Okay. And then yeah, back to the foot marks as well. So now I've done all of that. Then you can press escape to clear. And one final thing, because right now it says it is not a closed figure, but there's actually 2 vertices right here at the start and the end. One sits directly on top of the other. So I want to get rid of that, that extra one. And there's no real way to do that once they're sitting on top of each other. If you if you hover over a grip, you could say remove a vertex, but if you're on the start and stop and they're together, it won't let you do that. So we're going to do a little trick here. We're going to go to our edit menu, the polyline utilities, and we're going to go to remove polyline, and we're going to say remove a polyline segment. And if we do that, we're going to point to our polyline here and click on this little leg that comes off of this upper corner right there. So that's now removed. So I now have, there is my POB, goes all the way around, it comes up here, and there was my last leg. And there is a closing leg, but I've taken that out so that I don't have that double vertex out there. So this is fine, like we've got it right here. Just get rid of that, that last little segment, okay? And now what I'd like you to do is to select the polyline, and let's just rotate it. I'm just going to click a spot in the middle and just going to arbitrarily give it a, a little bit of a rotation differential. So it's not exactly like our original figure, and the figure's vertices have been tweaked a little bit around as if they had been either, placed in the wrong location, or they got bent or got moved or whatever. So we're going to use that to be able to compare. We're going to create some points out here on the ground based on this copy, this slightly skewed copy. And then we're going to be able to compare those points with our deed expected points and see which ones we should hold and what rotation we should use, etc. Okay. So To do that, we need to put points on every vertex of this figure. Several ways you can do that. You can simply go to the points menu, draw locate points, and then snap to the endpoints. That would work, certainly. It's not that difficult to do. But it's also a tool available to us on the COGO menu where we can create points from entities. And if we do that, it lets us choose a symbol. In fact, I'll go ahead and switch this back to just this little plus tick. And it says same description for all points. Let's just call them field. And let's say I'm going to start with as a point number. Okay. And now it wants to know, okay, so I'm going to create a bunch of points. I'm going to start with point number 101. And I'm going to give a description of FLD. And now what do you want to process? Because it's going to ask me to select something to process. And I could choose any or all of these things up here. So you can see if you've got a bunch of, let's say you've got a map that has a bunch of spot elevations that are just text. Well, you can choose, this text, and it will read the insertion point of the text and create a point there for you. So there's all kinds of usefulness to this. But I do know that this is a polyline, and all I really need is that polyline. I don't have any arcs. There's an arc that is a part of this polyline, but it's included when you choose polyline. So you don't need to have that on, but it's there. Circles, etc., all those different things. Now, when you're processing that entity, when you're in the middle part of or the middle part of this dialog box says, when you are on curves, do you want to calculate and create midpoints and radius point, or do you want to skip them? Well, we're going to just skip them because, the original surveyor would not have documented those points out on the ground. He would have just had the corners, the endpoints of that arc segment. So I'm going to skip the radius and skip the midpoints. And then down here is how to control if you have any point, points that are missing, that sort of stuff. And we'll say, okay. And it's asking me for a surface model. I'm going to just say cancel because I apparently told it to get the elevation from the surface model. So let's go back to that. First of all, before we do that, while you're here, since you've just loaded this file up, you probably don't have any points. If you look up on your screen at the top, do you see something showing for coordinate file? Right now, mine says deep processing.
No, it says none.
And I've got these 7 points. I'm guessing most of you probably won't have that if you loaded this file. So if you do not, go to the points menu and set a coordinate file and call it whatever you'd like to call it. Processing is fine. And then go to points menu, point utilities, and update the CRD from the drawing. Follow your prompts, select all of those points so that you get points 1 through 7. Okay. And then verify that when you're done with that by points, list points, making sure that you have all 7 points. And they should read like that. Okay, everybody got that part correct? Okay, there's from Mark's got a thumbs up.
I'm all set now.
Zoe, got those?
Mine's still not saying I have any points. So I went to points, I named
Oh,
it, it's
goodness.
now the CRD is deed processing from class. And then I go to points and
I didn't
point
see it.
utility.
I didn't see a thumbs up. I just saw that it came into focus as if you were going to speak or something. Everybody has it okay?
Can you
Zoe
hear
and
me?
Carl?
Can you hear me?
I have it.
Can you hear me now?
Okay.
Hello?
All right, so assume, Zoe, if you were saying something a second ago, I didn't hear it. I don't know.
Can you hear me now?
You're not showing as muted, but
So yeah, I can hear you. I don't think Ken can.
Okay.
not sure what's going on. All right, so pushing this on ahead. So if we want to create points on that element, we're going to go to the COGO menu and choose create points from entities. We'll set our symbol if you wish. Layer name for the points. I'm going to also put that on a layer called PNTS_FLD. These are points I found in the field. And now I'm going to uncheck this elevate by surface model so it doesn't ask me for that. And I'm not going to ask for elevations. I'm just going to read that figure, which will all be zeros. That'll be fine. So point numbers start with 101, and that should be fine. I'll say okay. I will make sure polylines is on, make sure I'm skipping the radius and midpoints. I'll say okay. I'll select my feature. And once that's selected, and I hit enter to finish the selection, it's going to create 101, 102, 103, 104, 105, and 106. Okay. And we're going to use those points now to see how we can correlate to this set of deed points. And that's what this next tool does. So under survey, deed tools is a program called deed correlation. So if we choose that, it's going to ask you to specify a deed correlation file that you want to process. Well, we're going to select the new tab and we'll call it, I'll just use this one that's technically already existing, but because I'm saying new, it's going to overwrite it. I'll say, yes, go ahead and replace it. And now we get a dialog box up that has our list of points that we're going to create. Notice there's two columns, one that says survey point, one that says deed point. And we can just add points. And we could give it a survey point, which would be, we could pick from the list, which would be 101, for instance. And the deed point that we want to compare that to is number 1. Okay. We say okay, and that adds that. Now you can shorten that up a little bit and you can simply add a polyline and choose that. I'm sorry. Let me do that. Let me run this one more time just to show you what that will do. If you add a polyline, you can choose, it says select the survey polyline, which is that one. And now select the deed polyline, which is that one. And it says that they have different number of points. That's, yeah, understood. All right. Just show you what, this is actually a new feature in this version. If I add a polyline, say this polyline to this polyline. See what it does is it finds the points along there. And that S7, that's this point that was artificially created, and it compares it to point number 7 in this original polyline. So that's one way to get those in there quickly if you want to. But you have to have the same number of vertices. So what we'll do is just very quickly set this back to the way it was. And I will get rid of that. So everything matches what you have. Okay. So now we've got points from one to the other. We're going to run our deed correlation. And we're going to add some points. And the points we are going to add, our survey points would be 101 to deed point 1. And we're going to add 102 to deed point 2. We'll add 103 to deed point 3. We'll add 104 to deed point 4. We'll add 105 to deed point 5. We'll add 106 to deed point 6. And then finally, we're going to add, because we do have another deed point 7, but we don't have a 107, we have a 101, and we'll use that to compare to 0.7. So notice you can have, and let's say you found a point out here, but you've got, or maybe you've got 3 points that you found in the field. You're not sure which one is the right corner. You've only got, one corner over here on your deed. So you could, add in like 101, 102, 103 and compare them all to point number 1 for your deed to see which one of those would be the better point to hold. So there's, these don't have to just simply be a one-to-one correspondence. So that's an example here of this 101 is going to compare to deed point 7, which technically 1 and 7 are the same point, but the deed doesn't close. So, but you get the idea of what we can use this for, okay? And so now we want to talk about the alignment direction. So if we're trying to bring the points from the field and line them up with the points from the deed, then you would choose this direction to be from survey to deed. But really, if these are the ones in the field and they're typically done on a proper coordinate system basis, either state plane or some kind of local system that matches your other work, then you want to take your deed stuff that you just put in arbitrarily as a start point, and then you want to resolve that into where it actually fits on the ground. So that's our deed to survey. All right. So now we have these buttons that are going to step us through this process. And the first thing you might want to look at is an inverse report. So if we click that, we're going to see that we have the survey points on the left, the deed points on the right, and it goes through each one. It's going to start here and hold point 101, and it's going to inverse all the way around 102, 103, 104, 105, 106, and then of course back to 101 because that's in their list of points. That one's sort of not necessary. But correspondingly, it's going to hold point 1 and then inverse to 2 to 3 to 4 to 5 to 6 to 7. Okay. So technically these distances here, this distance 1 to 2 is 165.450. 101 to 102 is 165.445. Pretty close correlation. But here's one from 101 to 103. So it's sitting here and it's going all the way across the figure. And when it looks at that, that's our field point, it's 213.2, whereas it's 2.212.8 8. And so, not as good, not as tight a fit, but not too bad, all right? So this is a report that you can use to help you analyze all of those different things. And you don't have to sit around and do, 1,000 inverse commands. It just gathers it all up for you and puts it in a nice report, okay? Then you've got let's say you've decided that, well, from what I've seen, it looks to me like if I hold point number 105 down here, and I set my rotation from 105 to 103, maybe that's what I think is going to give me my best results based on some other things I may have found, some other evidence. So I'm going to look at this compare before align. And so this is going to show me actually this part is just lining up the differences of my field points into my deed points. So it doesn't really, because it's so widely separated, this one doesn't give me a lot of really useful information other than I see here with this one, 101 to 1 compared to 101 to 7. And then I could, maybe have computed that from my previous inverse report. I may know something that I'm looking for in terms of a target. So, but these other deltas don't really, 102 to 2, and that's just delta Y, delta X, and delta Y. So these don't really mean a great deal for us at this point, other than if I'm comparing multiple field points to a single deed point or something. You can check and see, which ones are going to be about what you expect them to be from your inverse report. So that's just a point-to-point comparison. So next we're going to check this alignment, and this is back to what I was talking about. Let's say if we hold 105 and we rotate into 103. So let's check that alignment, and it's going to ask, well, actually deed points, so 5 to 3 instead of 105. But if I hold my 0.5 as my pivot point, and I'm going to use 0.3 as my rotation. So if I do that, I'm just going to use that to check. If I check that, it tells me, well, holding 0.5, which is 105 in the survey, 5 in the deed, to 103 to 3, here's what's going to happen. That means I have to move my deed 462 feet in the X or the east and drop it down 2.3 feet in the north, and then rotate it 14 degrees in 25 minutes, 14.5 degrees. And it gives me an average residual, an average difference of 0.4 feet. But here now my deltas are going to start to mean a little bit better. I can say, well, that gives me, I got a pretty good agreement here, at least in the X for 0.3 to 103. But if I look at this distance column, they're all pretty much 3 to 103 has the best fit if I hold 105 and rotate, or hold 5, rotate to 3. Okay. So this is just a means of showing you what happens if you do that and you rotate them around. How do they fit? That's the check alignment. But it also has a find minimum alignment where it will find which point to hold, which point to use to rotate with, that will give you the best fit, will give you the smallest residuals, this residual distance here, and that's this column under the distance to make all this stuff fit. So it will tell you that we need to hold this point right here, and we're going to hold this point down here to set the rotation. And if we do that and then pick it up and move 2 to 102 after we've done that rotation, then that will give us the best fit with all of those other points that we found in the field. Now, that being said, obviously, as surveyors, those of you who make those decisions as you are resolving your field evidence, evidence trumps math always. So if you've got, anything in the field that your evidence is pointing very heavily to hold one thing over another, then that's what you're going to use. That's your charter as a surveyor. If, however, all other things being equal, you just want to see what's our best fit mathematically and then start to look for that evidence, then you will use this tool to kind of give you the best approach at making those, it's a starting point to start to make your evidentiaries solution. Okay. So once that's done and you found that minimum alignment, you can then apply that alignment. And if you apply that alignment, click that button, it's going to ask you, okay, well, what range of points do we want to move? And there's 1 through 7. That's all our deed points over here. And you could say only move, say 1 to 6 if you'd like, or you could have a group, etc. Filter it by description. And it's basically then asking you, well, what's the first source point that you want to use? And that's using 0.2. That's our hold point. And it's going to pick up 2 and move it to where 102 is. And then for rotation, it's going to take that whole group of points that it's moved over here. It's going to sit at 102 and look at 104. And it's going to rotate this group based on 2 looking at 4 to match that same rotation, 102 to 104. So that's what this is doing. So it's holding 2, rotating into 4, picking those up, bringing them over to 102 to 104. Now, if you are only wanting to bring the points over, then that's fine. You could leave this align screen entities alone. But because we've drawn this figure and its labels and such as our deed, we could have maybe a house and a tree and a road outline, that kind of stuff. So if you say align screen entities, that means align other non-point data, the graphics on the screen, as part of that move, if you'd like. Okay. So we'll turn that on and we're going to just ignore elevations. We're not worried about the elevations at this point. And we'll say, okay, now here comes a very important concept. It says select the objects to align, but points excluded. So it's asking us to select entities. We read the line above, select the objects to align, points excluded. And here's why, because if you were to grab the points and then you let the command finish, it already is going to move the points. And then because you've selected the points, it's going to go to the next step, which is to bring all of those things that are drawn and make that move. So it will move it and rotate it that amount again. So it would pick those points up, move them to the field location, and then pick those points up and shove them over to that same motion away. So you want to make sure that you exclude the points. So I'm just going to select our boundary. I'll select our text, which I don't know. It may be because we have our labels linked that they may go along for the ride anyway. We'll see what happens. But that's really, and like I said, I could have other things drawn that I want to move. So now I've selected everything. I did not get my points because they're going anyway. And I'll hit enter to finish and everything picks up and moves. And it tells you that it aligns 6 points. And you notice point number 7 stayed where it was because I changed mine to say 1 through 6. And there's that leg for that red line that we took out of our yellow one. Now notice this over here got sort of moved. It's still, you can see where the insertion points are, but it changed where where they are. And you could either, you know, pick it up and move it back, or just re-annotate. See, it didn't actually rotate it. We'll take those same things, give them a rotation. Rotate there. Whoop. Rotates. There, just swing it around. All right, so that will bring those along for you. Now, so what do we see from this? If we zoom in really tight, you can see here's our field located point. And here is the shape of the deed from the deed cause. And we didn't actually, you know, we did not actually warp this figure. We took that figure and picked it up and just did a translation and a rotation. Okay, so we're not actually, but we did it so that we got the best fit based on this other evidence we found. And if I take this, let me take this point for a minute. I'm going to change it from that symbol to, instead of a plus, let's use a, we'll use an X. Okay, so, and I'll change its layer to green. All right, so the red plus, which is my 106 field point, it's on the end of the yellow. My green X is my point number 6 that was found, you know, from the deed. Same thing with 101. You see that difference? Up at the end of this line here would be that original 0.7. Here's the original 0.1, but here's my point 101. So that's how close that's going to fit. If you look in up here, because remember we held this point, those 2 points, no matter how close you get zoomed in, it's going to always be the same point. And the rotation, now these points won't be exactly on the same spot, but the rotation will be, unless I don't think I left. I may not have, yeah, there we go. We can finally start to see a little bit of difference. There you go, just barely. Wasn't much movement that we did there. Okay, so that shows, you know, right here, for instance, this may be, you know, a little bit too far outside of what we want to accept. Same thing down here, but you know, there's other reasons why those could be in different spots. But that's just a tool to help you come up with some processing there. Okay. Now, let's say we have used that. I'm going to just select everything on the screen and delete it. It's all gone. And let's go back to a couple of other deed tricks or deed tools. So remember, we saved that deed description where we entered the deed description. We saved it in that deed file called process deed file. And that was the enter deed.pdd. And it's got 2 lots in it already. I'm actually going to just remove that old one. This is the new one that we have. And here was our deed that we had. We'll say, okay. Come back to that. We'll select it and we'll just say draw. And we're going to put it on On this layer, we're going to have it erase previous drawings. We'll label descriptions, lines and arcs, etc., and say, okay, there it is, and exit. Definitions say, yep, we'll save it. So there now are our points. And again, the descriptions are just pieces of text. They can be moved around, do whatever you want to. There are no actual points in there. This figure is still not closed, and it's that original, that overlap from point 1 to point 7. Okay, so how do we compute our closure on that deed? And that's some of our tools here as well. So we've got closure by point numbers. Now remember, we have points 1 through 7, so we could do that using the points, or once we resolved those. Now remember, points 1 through 7 are over here now, or 1 through 6 are. So we could use point numbers, or we could, let's see, let's do the map check by screen entities. So we're going to choose this, choose the line work to process, which we did. And now it says choose a sample of the text. So I'm just going to choose one of the distances, one of the bearings. We could then set up, what controls the distances. And I think in this case, we've got feet to be that little foot mark. It's already set up for us, so that part's okay. Bearings, we've got N and N, S, E, and W. That should be okay. Arcs. Yeah, these are the, see, D, R, and A. So D, R, A, that should tell us what we need for that. We will say okay and hope it works. All right, so yeah, there we go. So it read the line work and then compared it with these labels as it goes along. And so you should see that it's actually north 25, 30, 45, 165, 45. So there's that first one. Then it read the south 45, 200, all the way around. It also picked up the curve nicely, identified the radius, and let's see what else we have now. The 200 foot and the 4930 on that last closing line. And it computed the coordinates for that last point as being just slightly off of that one. Gives me my area, gives me my distance, gives me my misclosure, so like 100th, and there it is, 1 part in 89,000. And then you could save that into a deed file if you want. We'll just exit that out. So we've got that as an option. And let's do another tool. I'm going to select my parcel. I'm going to copy it over to here. I will say, zoom in here and get that one. I'll bring that vertex away from there so I can actually select it. I'm going to hover the mouse over that vertex and remove the vertex. Then I'm going to select it, come over to my properties and set the closed value from no to yes. So now I've got a closed figure, and you can do that same thing. Let's do let's see, a map check. Screen by points. See what else I can do with this. If I let's take this polyline now and make a deed file, and we're going to call this deed file from graphics. We'll select this polyline. Now it's done. I now have that as a deed file that I can load up. It doesn't have a name here, but I'm going to say selected P line as the name. I'll call it that. And I see that I've got 25, 30, 45, 165, 45. So those are all okay. The only one I expect to be slightly different might be that 49.3 closing is 49.29 or 289. Okay, so it still created an individual deed that I'll save and exit, so I can add that to my deed files, etc. Okay. So just a number of tools that you can use for your deed processing. You can check, let's see, that's get rid of those. Let's draw locate points. I'm going to choose these circles. I'll draw a range of 1 through 6. And then let's draw a 2D polyline. And let's choose boundary lots. Set our color to by layer. And I'll say okay, and I'm just going to go 1 through 6 and then C to close. There's now, that is no longer with an arc, but because that had an arc that had a radius of 200 feet, you could put in a circle of, or an arc of 200-foot radius. And let's see about doing that. So if we draw an arc, what are our choices? We could go PC, radius, and PT. That's what we know. So there's our PC, which is point number 4. The radius is 200 feet. The PT is point number 5. And it's drawn it in that direction, asking us if that is the correct direction. We're going to say no. And so it's going to flip it the other direction. All right, so now that is the line that I really need to use. So I'm going to get rid of this gap, or this segment. Remember, that was edit polyline utilities, remove polyline segment, or I'm going to look for that icon up here on my toolbars, which is this icon right up here. It says remove polyline segment. So I'm going to choose that, choose this polyline segment, be done. Now, I've got 2 different things. If I want to join those back together, I would use join nearest. Also on the polyline toolbar, it's also available under the edit menu, join nearest. And in this case, because I know they are exactly on the same point, it doesn't matter what I choose here or what allowable gap that I have. But I will just say average those endpoints together, different filters, what I'm using, the identical layers, line types, elevations, etc. I'm just going to say okay. Now select all the things you want to join. Now, if you select them, the last one that you select will be the one whose characteristics it uses. So I'm going to select my white one first. I'll select this one next, and off they go. Now, this figure has been joined from there. Oh, I forgot to get the other part. So I would simply do that again and take this one and join to that one. Right, so now there's a complete, you see down here it is closed, complete polyline, but here's another thing that you might need to fix. Notice vertex 1 is now over here and not over here where a point 1 was, where it started. Okay, so there is a way of fixing that, of resolving that. Again, it's an edit function. And you could draw the polyline start and end so that would show you where they are with certain symbols if you weren't sure about where something started. If we edit our polyline, set the polyline origin, select the polyline here, and so it wants you to pick near the origin point. So if I just hover there and click, it's now changed point number 1 to be up here. And there's 2, 3, 4, 5, 6, and then back to 1. So you can reset the origins if you need to. You can change the direction of them if you need to, again, on that polyline edit toolbar. All right. So now, if we did our closure by point numbers, if we say 1, 2, 6, and process, notice what it's doing here. This is just like from our edit process raw file, which is a no adjust. Now we're going to see a no adjust. Again, that closing points are just as if it's a traverse, right? Of course, it's going to give us, the fact that we went to 6 and we didn't go up here to 7, which didn't get included in the first place. So that's up there, that one part in 18, because we got that big misclosure right in there. So if we had, let's see, 1 through 6, and then let's add 1. So now we've got a closed figure. Let's process that, no adjust. Reference closing point optional, it doesn't matter, it's the same. Starting and ending point 1. So now we've got one part in, what is that? 16 million. So pretty good precision. Close flat out. And it's the reason you've got this little amount is because of some round off just in the decimal places. Okay, so that's something there that you can do. Then you can save that to another raw file and edit that raw file. And if you do that, and we'll call this one from deeds, let's just call it. Exit that. We'll go back to edit process raw data. Go open from deeds, just so you can see the shape of it. And there it did, it stored point 1. And then it traversed 2 to 3, 3 to 4, 4 to 5, 5 to 6, and then it had a closing shot and an angle balance from 6 back to 1. Okay, and you could take that little bit of error resulting from those round off decimal positions. You can actually adjust that out with these adjustments if you so chose. Not really a lot that you can need to worry about doing it. Okay. What else can you do with this? If you annotate, let's go to the area layout menu. And let's just do an area by closed polyline. We'll do a single. We'll label it, select it. That gives us 1.19 acres. There's a perimeter, so 52,000 square feet. We'll say exit. A lot description, 0.1, we'll just call it that. So your label may or may not look exactly like that. And here's where you set that up, is on your area layout menu. Look at your area defaults. And this is if you are looking for your label fields and settings. These are the ones that we choose to put in that label. And these are all the different ones that are available. I could, set this up with cuerdas and square kilometers and hectares, etc. All of these different things I may or may not want to use. So right now I'm using a lot description and then square feet and acres. Now I've got lot description and I'm using a text style called slant, which apparently is not defined. If I select it, I mean, it is defined now, but it obviously doesn't. I would have to go and redefine it to put the slant on it if I want. Here's my text size scalar, meaning 0.1 inches at my selected scale. The layer, etc. Any prefixes and suffixes, how I want to justify it. And I've got this one called user defined, which I have no idea what that, and that's that blank line. So that's not really anything that I need. I think I may have just had it in there to make the blank line. Okay, my square feet, if I set that up, I've got a prefix of none, a suffix of space SF. That's why the number and the space SF. Means center justified, no plus or minus mark there. And the precision is set to the nearest foot. Now, why is that? Yes, rhetorically. We'll talk about that in comparison to this one under acres, which I see now I have a suffix of space AC, and I'm using the plus or minus symbol as a suffix, but my precision here is to the nearest 10,000th of an acre. And the reason I've formulated this in that regard is because of significant figures. If these acres, because at 1 acre is 43,560 square feet, so it is on the order of 10,000 square feet, or its order of magnitude is in the 10,000th place. So a change in my individual feet would affect a change in the 4th decimal place of my acreage values. Or likewise, a change here would affect a near square feet. So if I take my square footage out to the 100th, say, 2 decimal places, to match it in terms of sensitivity to change to this number, I would have to add 2 more decimal places to my acreage number. So that's the reason why we do that. I've seen maps and stuff where we'll give the nearest 100th of a square foot and they'll put it down to the nearest, 10th of an acre, which that's not really an equivalency, that doesn't tell me much. But whatever you choose to do, you have control over it in that regard. Now, so that we know how much is in this parcel. I'm going to save this, and we're going to use this to do some parcel division things when we come back after a break. Okay. Any questions on anything at this point?
I'm good.
Everybody good? Okay,
Yeah,
Joe's good,
all good.
everybody's good. All right, we'll take a 10-minute break, so we'll come back about 10 minutes till the hour and pick up from there. Okay. So I will see you guys at 10 till. Okay. So we have seen a couple of tools that we can use to work on some deeds. Let's take another, let's take a pass through some of the tools for some layouts as well. And we could do some adjustments, some partitioning tools that we'll see here. We'll lay out some layouts for some multiple lots. We'll just run through a couple of things, and that'll set us up for later on. We'll go through our lot network and set those up as our final pass through some things. But we'll finish up with these tools here coming with some typical things that we might do as surveyors. So we've got a lot here that's a little over an acre. Okay, and so if we want to partition this lot, let's say we want to bring, let me see, let's do this. I'm going to draw. See here. Polyline that I'm going to follow. I'll check this. I'll start there. And I will go to here. Wrong direction. Go that way, yes. And then continue. Not like that. And then to offset. So it's a 50-foot right of way. All right, so here's our scenario. This is our road, our parcel, and you don't have to draw that. I'm just giving you an idea of what it looks like. So this is our parcel, and we're getting ready to we want to subdivide this into either a 1 acre that's a half an acre, the rest is what would it be, like 0.6, or we could divide it exactly in half. But in any case, we want to do that by a number of potential ways. We could, compute, say, from this corner back to a, and take that radially from this curve and do that kind of stuff. Or we could simply, if we want to take this side and slide it, that would be our sliding side adjustment. So we have those controls under these adjustment. We do a hinged area or a sliding side or radial from a curve or a particular, specific bearing. So if we do a sliding side area, I'm going to choose that command. It says define the area by points or a closed polyline. Well, let's just use the line work. So we'll take that L, or it's in default, we can just hit enter. And so the segment that we're going to adjust will be this segment out here. And it says, do you want to keep the existing polyline? Well, let's go ahead and keep it. And now we want to define the new line by a selected line, another line, angle, or points. So let's use the selected line, what we just picked. And we need a target area, either in square feet or acres, square yards, or we want to define the remainder. So if we wanted a square, or no, I'm sorry, if we wanted, a half-acre lot, we would say A for acres, and we would say half an acre, and there would be the parcel created by this line that is a half an acre lot. Now we kept the original, which was here, but just to show you what these two things are, let's go back to area layout. And let's say area by interior point. I'll pick a point here and call that 2. Wait a minute, it's not. I think what I have to do is turn this into a polyline. So if I edit that polyline utilities, say entities to polyline, we'll select that now. Let's see if we do that. So if I say area by interior point, no. Huh. It's not finding that, is it not? There we go, trim. Why it's not finding it. Let's see. Let's do. Well, let's do it. See, that should work. Well, that worked there. Try that 2. There's that acre lot. Sure, we'll keep that one. All right, so what must have happened is that that line probably did not go all the way up. So when I did a trim and I extended it out to actually intersect that, that's what divided that together. So when I did this sliding side area and I said a half an acre lot, it pushed this line out to where the lot that it creates out here on the end of it is half an acre. If you wanted it to be this end up here to be half an acre, we would have to have chosen that as the remainder. Now, I'm not really sure how you know which one of those is going to be the one you want. It's based on the direction that the lines are created in. So really what you'd have to do is try it once, see if it works. If not, do it over again the other direction. Okay, so Now these are linked. Let's see if we can adjust that one now. I'm going to take this one. Let's see here. I'll take this closed polyline and make it green. That one I'll leave white. So with this one, let's try that to make it exactly 0.5 acres. So if I do an adjust area, sliding side, select it by line work. There's the line I want to adjust. Keep the existing polyline. Let's say no. And I've defined the new line by selected line, another line, and your points of the selected line. And the target area in acres. So there's half an acre there. It doesn't make. And so if I did that now, area by closed polyline. Yep, there's my half acre instead of 0.69 acres. Whereas this is that overall. Previous one, okay? So that was an example of some of those tools that we can use to modify, and I'll take these two guys out. This one out as well. So we're going to use that to modify these lots into our partitioning as well as to change an existing lot. So we know that was 1.19 acres. If we want this to be just say a single acre, if we adjust by, let's do a hinged area this time by line work. We'll select this. The hinge point will be here. Keep existing polyline. Let's just say yes. And we want the acres, instead of being that 1.19, let's just call it 1 acre. There now would be, if I extend, if I extend this, do that interior point, excuse me, then it creates that lot of exactly 1 acre, then leaving that 0.192 acres or whatever it is over here, okay, by swinging that line. That was the original. Okay, so a couple of things to do there. Now, supposing, excuse me. All right, so supposing we have a situation like this. Let's draw a 2D polyline. And let's see. At this point, let's type a arc, a type A for arc. And we'll just show it like so. And then extend, let's give it a distance here. Make it tangent. All right, so there's now a polyline with arc in it and another piece of tangent. I'm going to draw another one. And I know that this is about 50 feet, so I'm going to go here, say maybe like 100 feet and just sort of go across. You know, just sort of arbitrarily done like so. And let's go ahead and close this thing off. That. And that I will join nearest into a single closed polyline. There it is, closed polyline. And it doesn't have to be closed. In fact, let's just to show you the difference here, let's take these off. Yeah. Back to our layout in terms of our utilities. If we do some lot layouts, we would go ahead and choose that. And let's make, see if these were full, that's a full acre there. So let's make these say quarter acre lots. Okay, that's what it's set to there now, quarter acre. A minimum frontage of 50 feet, no minimum back lot, and whatever remainder, we can either add to the last lot, you create a separate in lot of just the remainder, or you can distribute that equally to all the lots if that's what your choice to do is here. You could have a setback polyline drawn here so that the actual, you know, maybe this is the center line of a road, and you've got the offset, you know, back here that you want the area to be calculated at the setback line. So prompt for each lot area, set the number of equal lots. You can tell it how many lots you want to make, or you can have it go to this target area and make as many as it wants. And then how do you want to draw those lots? Either as complete closed polylines or just the sidelines only. So let's choose our sidelines only. We'll say okay. And wants me to select the frontage, which is here. And then if you have an offset, you could type O. Again, read the prompts down at the status line, or the command line rather. Or simply go next to select the back polygon. So there's now the back, and there now is my lot layout of 1, 2, 3, 4, 5, 6 individual lots of quarter acres, and looks like the last one was where we threw the remainder. Wasn't quite enough to make an additional quarter inch or quarter acre lot. So it threw our remainder into this lot. If we want to take a little treatment of this whole thing, like just like we did on the deed processing where we could have multiple deeds, well, we could create lots now by, we'll pick these interior points and let's set a lot file. And let's just call this one a simple simple subdivision. Okay, so now I've set the file that I want to use, but I haven't done anything with it. all I did from this point was I did a lot layout, which just drew lines. I haven't really turned them into lots yet, but it created the lines where I needed them to be. But if I want to create lots and put them in that lot file, then I'm going to do it by this. And you can do it by interior text, by closed line work, had I drawn those as closed polylines, or you can use a polyline to a single lot, or you can actually do the design lot where you type in much like a deed description on each lot. But I've already got the geometry drawn. Pardon me. I promise I don't have COVID and I won't give it to you. I have been tested actually. So if so just because we've got the graphics, let's do a lot file by pick interior. So when we do that, it wants a starting point number. Well, let's make these start with say 0.501. We'll call it corners. We'll draw the points. Block name, we'll just call, let's call it block A. Clockwise point order, combined common angles, that's fine. Say okay, pick a point inside. So if it finds that, and now it wants to know the lot name down here in the bottom, I'll just keep it as lot 1. Okay, so it created 5 points, 1, 2, 3, 4, and then 5 to close it. Pick inside the next one. It's gonna be lot 2. We'll create those points. Pick inside the next one. There's 3, 4. Notice it creates the radius point. And it will create another radius point down there on top of that as well. And finally here, lot 6, and then enter to end. Okay, now I have a series of lots. I've got points. I can use those to stake out. Notice when it drew the points, and remember my points, when I did a point, draw locate points, excuse me, the symbol that I used was the one that had the wipeout in it that we talked about yesterday. If I turn my frames on, you can see those features, the edges of the frame, which can't be circular.
1 sec.
Oops, sorry. It's a problem. Siri thinks I'm talking to her. Anyway, so it just uses the current settings for the points to create these. So that would be my lots. Now, what have I done? Even if I don't have this drawn, or if I go into a new file, I can, as long as I have that file, let's go to our lot file manager. And let's open our lot, simple subdivision lot. There's our lot file. I can see, where these files, or where these lots actually are in the ground. Okay, I could work on individual ones, select them, change this. I can, assign them to different groups, etc. Can zoom, highlight, hatch, restore the view on exit. What else can I do? I can, let's do a report on all of them. Let's see, report area and perimeter only. That should be fine. Check lots report. So if I check the lots, let's see what happens here. I've got lot 1, 2, 3, 4, 5, 6, and you can see the, actually this should be like so. We'll block back and send it over. So 1 through 6, you can see 1 through 5 had that full quarter acre. Lot 6 is 0.2513. I've got this total area. I can Oh, let's see what else I can do inside. Again, if I edit, let's go to lot 2, for instance. So if I click the edit button on lot 2, I can make individual changes to their labels, to their groups, types of what I'm using here, the starting station and ending station. That's starting at its POB, walking itself around the perimeter. And you see individual points, 501, 05, 06, 02. And then back to, let's say, 01 to 05. So apparently, all right, 505, 06, 02, 01, and then back to 05. So you can actually change those. You can set them to be radius or arc points, right? And put them off into different coordinate files by selecting up here. You can reverse their order. You can set the POB at a different spot. Okay. So we can edit those individually as well. And you can even, let's see, if I change yeah, so if I change the geometry of these individual points, so I'm setting 0.501 is to be a radius point. If I do that, it's going to change those edges into being a radius. So you can make those, and again, you put your deed book volume and page, group, block, and lot, etc. And if you then make edits to those, and you can then redraw the additional one, you can add additional lots. So it keeps things current for you. Let's go to our last one now. Sorry. Let me choose this, not that one, but I want this one. Pick a point inside. Let's say nope. Yeah, so 0.6 or lot 6 rather. Didn't clear the hatching, which it should have from 1 to 6. There we go. Now, if we take, say, 514, which is from this previous, take 513. Do 16, 17. It's going to cross some things over. So anyway, I've got this methodology of creating a group of related parcels that I can draw and assign to different blocks, different lot numbers, different types if you've created different types, and then edit these individual ones to change their behavior within the bounds of what you can do, whether they become large arc points or radius points. if I want to actually change how these behave, then so let's say any changes there. Then let's do this. Let's take lot 5 or 0.514. And if I move 0.514, and I'm going to put it at the, let's put it along this line, say here. Okay. And now, if I go back to my lot file, see how lot 6 has actually responded to that change in that point location, as has lot 5. So it's now in that new location. Okay. So those are the lots. So I would then actually need to, if I wanted to update my drawing, oops. I need to just rearrange those graphics. Or I could simply have drawn, if we leave that like that, go back to my lot manager, and let's choose this lot here, lot number 6, and we'll draw it. And let's go ahead and label everything, created one lot polyline. So created it and labeled it. You could select all of them, draw them. You need to hatch or draw points, and there now is everything that you need. We'll exit that. No longer really need this guy. It's just used to create. And they're now complete with a common bearing. So it's consolidated those 3 distances, or 4 actually, to that total distance. It's got the interior distances, the lot numbers, and the acreage. And you can see how that worked as well. So again, if you wanted this one to be 0.25, you could take this as a sliding side, or you could use it as a hinged side from there and target that as 0.25, or you would maybe not have changed that in the first place. Okay. So just some individual means of lot layouts. So keep those in mind, and we will get to some of those sort of on steroid behavior patterns with lot net, this actual, these commands here in the middle, the lot network. And you'll see how that works on an overall entire subdivision that you might want to work. A couple more things with an individual lot file, and this is a lot file as opposed to a lot network file. We'll see that toward the end of the, actually that'll be the last part we look at the end of the day. But some other lot file utilities. If you do a lot file inspector, so as you hover over these things, let me see if I can open this up a little bit. There we go. So you can see that it's going to report you, where those things are made from. It tells you the coordinate file that those points live in, and the points that you are, not sure which, let's see if I, yeah. If you hover, and I'm snapping there to that endpoint, I'm just hovering, I'm not actually snapping, but you see the point numbers in the inspector are showing up. It says, so I move the pointer inside the lot. So I look down at my command line, and then it says pick to edit. So if I pick number 2, it goes straight into that editing business that I had before in my manager. And there's not really a lot you can do here in terms of moving the points around, but you can, change designations and stuff like that for that editor. Okay. And then enter to finish. So that's an option. Here's where you can define these lot attributes. Right now I've got a lot attribute with the lot number. Got another one called the deed book volume and page, where I added that before. You could add one, add multiples. And those can all be part of lot data that gets filled out and stored with those lot files. So we did this create by pick interior. Let's see, what else might we do? Lot layout. We the lot layout set. Yeah, here's one you can do for some of these. If you've got these lot lines, for instance, and these will be now they're shown to the nearest second, but they're done from the frontage. They are set perpendicular, which means radial from any arcs in the front. Okay. And then now we moved this one, so that's why it's no longer there, but it used to go like this. So it was truly perpendicular to that last segment. And then, of course, the ends are what the ends are based on the endpoints of those two lines. Now, so those are not going to necessarily be at an exact second of arc, but you have those tools if you wanted them to be under this cleanup business, under the layout utilities. You could set those to the nearest second, or you can set the intersections to be perpendicular, exactly perpendicular. Now they are, but if you want them to the nearest second, you're going to lose one or the other. You can create offsets, intersections, cul-de-sacs. You can elevate the lot lines that you draw, and that can be draped on a surface if you've developed a graded surface, or they can be based on the elevations of a roadway alignment and go at a particular point. And they can also go to can go a certain distance at a certain slope and then change slope for another distance and then tell it to tie back down to the ground at the back. So there's a lot of different options that you can use with those. Now, some parking layouts that you can do. Is you've got some perimeter tools, which will allow you to create a parking curb. You see here's an entrance or a half island, bump out, exterior corners, and again you're parking here and this is an island, extended corner, and an interior corner. Now talking about these corners, it's not anything up here, it's the corner of the lot itself. So that's an interior corner. So you're parking here and you're parking here. And the exterior corner is just a change in direction. So you're parking here and you're parking here, and that's an exterior or a convex corner of that parking lot. It would be like this one up here. If you have an interior, it would be exactly the other way around. It would be as if you came up here, came across, and then went up. It would be that shape to help you create these different corners. And so that's some of the tools to to create a parking lot. And then you can create them along certain elements. So if these are, let's see, these are individual parcels here. Let's see what we can draw here to make this illustrative. Let's just draw, I'm going to draw a rectangle. So draw rectangle. Let's draw this. This will be my property. And then if I'm going to, within that property, let's draw a building. I'm going to draw a 2D polyline, and I'm going to click this box to autocorrect for 90 degrees. I'm going to call this building as my layer. I'll set the color to be blue. I'll say okay, and I'm going to click here, and I'm going to go a distance of 35 feet. And the direction I want to go is, let's go based on a line to parallel. So there it is. And so that's fine. I'll type Q to quit. And now because I've got that, I've got a sense of, there's my 35-foot long building. And even if I'm not exactly perpendicular here, if I click, notice it snapped it to be 90 degrees because of that switch I used. So now I'm going to come up here and hover over here and come down. I'm going to hover here and come over. And when they meet, there's that intersection. And then I'll type C to close. Now, if that was new to any of you, what I just did with those hoverings, that's an AutoCAD thing, not a Carlson thing. And that is in my OSNAP settings, I've turned on this extension as a snap mode, endpoint, midpoint snap mode. And so anything that you're doing is, let's say if I want to draw a line, a polyline rather, check that out, correct. I just want to go from, say, here, and I want to go to the intersection of this bottom line over and this midpoint coming down. So if I'm going to do that, I'm going to hover in the end point and then pull out. Now, if it doesn't grab it, I'll go back and hover again. And now you can see it shows me those directions. I'm going to hover there. I'm going to come up here and hover until I snap to that midpoint, which I have on as my snapping. And then when I get down to those two places, I'm going to hit there. I can then go to, from that point, let's say I'll hover here. And then there's my extension of that. It can also go horizontal, vertical, but the extension of whatever direction it is. So I'm going to go along that extension, and I'll come from here and come across horizontally until it hits that intersection. So you see what I did? I went from open space out here, I went to this point that is the extension of this bottom blue line horizontally and the midpoint of this red line vertically. And then I went up to this point, which was the extension of this line to the line that comes from this point horizontally out and where those two things intersect. Now you can certainly draw all that stuff and snap the intersections and then erase those temporary lines, but that's just a means of using your tracking, your object tracking by extension. And again, from this object snap settings, and the entity snap tracking, that's enabled, and then extension is also enabled. So just a little trivia there. So now I've got this building, let's say, and I'm going to put a parking lot associated with this property here. And I'm just going to give it some different color. I'm just going to say start here. And I'm just going to sort of make some arbitrary shapes and such. Maybe that's the areas I've got to use for my parking. And then you can try your hand at some of these utilities. So if I do design parking along an alignment, if I start here, go to here, to here, here, for instance. All right, so it says there's no corner located with the geometry. So what do I have? So that's going to be an exterior corner. So I'll choose that one. Let's take the defaults. Let's see. So, to the left, to the right. Let's see if that's, oh, I didn't. Let's try that again. And parking. Let's see, that's designed inside the perimeter. Let's see if that'll give us a better shape. There we go. So the sides, different settings. Should be okay. With parking is showing red. So if I don't want parking, for instance, let's see what, there we go. Well, that was, obviously I've got some overlap here. So let's undo. Let's make this so that we can see it. We do this, and let's take the parking out of there. Let's also take it out of that one. But let's leave it there, but not, there we go. Yeah, it's not a real, it's not a real nice layout to park here and to park here, because it all any roads coming, you know, any entrances coming in, etc. So, but it's just a means of helping us create those elements and help the layout as we go on. So it doesn't really create anything in particular. But, you know, and as you, what I did there was I double clicked that and I got this automatic layout response. You can see here as well, if I stretch it enough, You see what it's doing in the interior? It's creating islands. And based on that being a parking lot. And then you can add, now again, that's just, they're just polylines. There's nothing special about those. But if you want to, let's adjust parking inside. So if we pick this line work, pick the perimeter point to adjust. If I want to pick this point, and that was the same thing as if I had double clicked it. I want to get to the I want to make this say an interior. Select. Oh, there we go. So when I do go back to O for I want to put these island points. Let's do this half island. So okay, and it says pick the center point for the half island right there. And the side. I guess it's taking the perimeter itself. And I'll do the same thing here and the side there. And then if I want to modify that, again, there now is my overall bounding spot. I need to get rid of these and relay out the parking. Okay. So again, some tools to help lay these things out. And I should have had my geometry set up, my distances, so that it was an even multiple of those parking spaces. But you could recompute if I erase by layer. My curb, so then I could do that as a parking. Side. So now it's recognizing those bump outs, and let's go ahead and apply it there, but not there. Simply come in here and take these away from my layout because I don't need those as straight. I would convert those to an arc and snap them to the outside shape. Okay. Same thing up here. Do a little cleanup. I would either make these conversions or just delete that outside line altogether. And same thing, get rid of the one I don't need. Or even, just simply get rid of those two as a space. All right. So there's a number of tools to help with some automated layout if you're doing any kind of design that you don't necessarily have to use the old divide polyline tool and count up how many spaces you're going to need. So it can help you do some nice layout if you're using those kind of tools. All right. And then, like I said, we will come back to our lot network at the end of the day today. But until then, we're actually going to head into lunch here a little bit and come back and focus on our field to finish business. Now, do any of you, or how many of you, do things like road design where you need to create alignments and profiles, that sort of stuff? And do you need, and what would you like to go over some of that kind of stuff in the last little bit before lunch here? Anybody on those? Or
I don't.
I think there are some exercises in that regard in, let's see, I'm on page 73. In the first portion of your guide, this putting it all together kind of workflow where you get to it, where you actually created a stockpile volume and then computed a borrow pit, then created the profile, a little access road to come into the side of that borrow pit, and then graded it in all together. So that'll step you through those pretty quick examples as well. So if that would be something you want to pick that up on your own, or of course we focus on that in the civil class pretty heavily, on alignment and profile development and cross section for road templates and such. There's a little bit that you can do in survey. Survey doesn't have the rigorous road design, like you can't really create a cross-section template of different materials to do for a road. But you do have these center lines. You can create center lines just by drawing alignments, and they can be anything. It doesn't have to be a road. It could be, say, an alignment of manholes for a sewer. And then you can station along that alignment based on these station commands here. And at the on the surface menu, where you're actually using to create your terrain models, down at the bottom part of that menu are some profile tools. And you can use that to cut through 10 files, those terrain models, or even for things that are elevated in 3D on the screen, you can use those to get a quick look at those in 3 dimensions. Turn profiles into profile files, turn those into 3D polylines, create points from them, and then you've got conversions of, and these are typically road design profiles. They don't have to be, but they typically are, and they can go into these different formats that you can then transfer over to a data collector to help you do some layouts in the field. And you've got some design pad templates where you could, that's how, if you go back to that first part of the design guide, talks about that borrow pit. That's where you basically draw the floor, tell it how much material you want to take out of the existing ground, or if you're stockpiling, how much you want to put down and add to it. And then it will generate the geometry necessary to set that at the right elevation and all the side slopes and such to go on. The civil tools in the civil module extends this to where, you know, it does pond design and pad design, and it lets you edit those after they're designed. This is sort of in the survey, you've got a bit of a subset to it. So it still lets you do those things, but you can't do an interactive edit with it once they're done. You have to basically take it and do it all over again. You know, scrap the work and retarget to a different set of numbers if you want. Got some GIS tools. Again, it's just a subset that comes out of the GIS module, but because it's more common for surveyors to use than other types of engineers, you get at least a taste of it here as well. But there's an entire module of GIS that you have at your, you have available, just like Civil has all of the center line. There's some extra cross-section tools, which you don't have here, and profiles that you have those extra tools in those extra modules. Okay. So then the last bit that let's take a look at before we break for lunch. And that's what a lot of surveyors do all the time. And that's what we call COGO, or coordinate geometry. And notice up here in our system, we've got a series of commands that you see over here on the right part of the menu. You see parentheses, LP, close parentheses. That means locate point. Parentheses, I, parentheses, that means inverse. And what those are telling you the little shortcut that you can type to enter that command. Now that draw locate points, LP, is the very same command as this one right here, draw locate points on the points menu. But it's also very commonly part of what you're doing in COGO work, so it's repeated here for you in that regard. The inverse is another tool that we do quite often. The occupied point, OP, that is, if you're getting ready to compute some points, then you're going to set up as an occupied point, and you're going to run either a traverse or a side shot or do those kind of different things. Now, I showed you a little bit of the shortcut with that yesterday, and that was in doing this information to inverse to set that up. But if you, let's say if we want to set on point number 514, we're going to backslide point number 517, and we're going to turn an angle of 90 degrees and go 100 feet and set our next point. So if we go to COGO and choose occupied point, it wants us to pick the point or the point number. So if I pick that point, which I'm not sure it did. Let's see if I don't know if I've got it didn't. If I have my settings, point object snap on, that way I can just pick by picking close to the word, or I could have typed 514. Okay, so coordinate geometry, occupied point, I'll pick at 514. And now set my backside method either by azimuth, bearing, none, or point. I'll take point as the default. I'll just hit enter. And the next point number is 517 that I want to use for my backside. Okay, so now I've occupied 514. I'm looking at 517. And if I go next to, let's set a side shot. Okay, and I want to go 90 degrees angle right. So it's all set up for me there in brackets. That's my default. It says enter angle right, or I can change, let's see, O for options. I can do azimuth prompting, angle right, that's my default. So I'll take that, I'll hit enter for 90 degrees. Up, so it did not snap. Settings. Point object snapping is now on. Now let's see if I well, it gets it that way, but it doesn't get it from the attributes. That's interesting. Okay. Apparently it turns it off. Nope, still on. All right, so now 514 by point 517. Pick a point or point number. So that should be snapping there based on that setting, but it's not. All right, so we got that there. Now we can do a side shot, but remember we have SS as a command. So all I have to really do is just type SS. And it knows where I'm sitting and where I'm looking. So I'll go 90 degrees. I'll go 100 by distance. I'll just type that because that's the default condition. So there's 100 feet, 90 degrees. And I'll put the elevation. I'll just hit enter for nothing. And I'll put the point description. And there it is. Okay. And then I'm done. I'll just hit enter. And it goes back to set up another side shot. See, at this point, just well, E, essentially with E to exit. All right, so that takes care of it that way. Now, let's suppose that I've done a bunch of stuff. And I get interrupted by the phone, and I said, well, if I want to do a side shot, okay, so it's going to go right ahead and do, whatever angle. Let's go 45 degrees this time, and let's go 50 feet. All right, so it's going to go there. I'll give it that elevation. I'll call it test, and I'll need to exit. All right, so it remembers where I am, but say I forget where I am, and if I just hit that and go, it's going to still go to where I last was. So I could go to the trouble of saying occupy point, pick a point, tell it how kind of backslide, tell it my backslide, and do that ready to go each time I'm ready to do it. But the real quick way of doing this is to simply run an inverse. And you inverse starting from your desired backslide point into the desired occupied point. So if I want to sit at 505 and I want to backslide 50, let's say 502, but they don't have to have lines drawn between them, obviously. So I'm just going to I for inverse, and I'm going to say 502, and I'm going to go up to 505. Well, that has now set me to be my occupied point. Now I can, at this point, type SS for side shot, and let's go 90 degrees, 50 feet. That, we'll take another point there. Then let's go 180 and 50. And then we'll be done with that. Okay, and so there now I set that point that's 50 feet perpendicularly from that setup, and then it's 50 feet just extending from that setup. And I've created those 2 points that I can use for whatever means I want to use. And again, just by using those real quick points. Now, the difference between side shots and traverse, of course, is if I inverse, let's go back to my original, I'm going to inverse 517 to 514. Okay, so now so inverse from 517 to 514. So now I'm there, and I'm going to do another side shot. And let's set this one as, say, 270 and 200 feet. It's there. Let's do another side shot. It's still in side shot mode. So let's go 320, 200 feet. There. Go. Now at this point, let's say traverse. And so I'm still sitting at 514, looking at 517. I'm going to go 90, and let's go 200 feet. And at this point now, I'm now sitting at point 113, which because I moved the screen, you lose where that was setting up. But now I'm sitting at 113, looking at 514. And so if I go 90 from there, see, there's my setup. And let's go a distance of 50. And there's now that point. And now I'm at 114, looking at 113. I'll go 90, 50. Put that up. And one last time, I'll go 90 and 50. Set that up. And then E to exit. Now, if I draw a line, a 2D polyline, from 113 to 116. Oops, sorry. 113-116, and then close. So remember, I traversed my way around to 113, then set 114, 115, 116, and then I could draw lines to connect those points up, and I've now created a little 50-foot sided, excuse me, sided square, which if I annotate that, put some survey text, let's put building dimensions on that. We'll set that up. There you go, 50-foot square figure. I do a rectangle by 50 feet. Now, me as a CAD person that has been using AutoCAD for, as long as it's been a product, I would tend to draw a rectangle. I would click a point and I would go at 50 units to the right and 50 units up. And I would create that same feature like that. And then if I needed points on it, I would go to Kogo and create points from entities. But I used to work for a guy who's a surveyor, and he's used Carlson software from the time it's been a product. And he would come in every time he needs to draw something, he traverses his way around those shapes. And he normally would turn on, he would go here and say line on. And then he would say, let's inverse from 114 to 113. All right, so I'm now there. I'm going to say traverse. We'll go 90. Go 100. That. And we'll go 90. 100. And then finally 90. And then I would exit. So that's the way he would have done that. And now it's just say created lines, you can turn that into a polyline. Well, that's a polyline. So when you turn line on up here, that creates a line when you're traversing. He's dropping points as he goes and connecting up the points. Now, there's nothing wrong with doing that at all. You can create points and then create line work between the points. If you're more comfortable doing points, that's absolutely fine. But just remember that what you have created by the time you're done is just nothing more than a polyline, or in this case, a line, which you can turn into a polyline and join those all together. And if that's all you're after, there's no need to create points, but you can if you will, and nothing is wrong with that. Whichever is easiest or makes the most sense for you. Okay. We'll take a real quick look at Visual Kogo. We'll just do an inverse And I just want to show you what it brings up is it sets up a little tool space that basically is these commands up here in the menu, but it's done up here graphically. And so if I'm going to inverse, I'll choose my inverse command right here. And I want to, let's set up my setup as I want to sit on 512 and look at 116. So I can go from 116 to 512. I can pick it from a list. Okay, so there's the inverse, 116 to 512. Now if I, let's do some side shots. So there you saw the setup. I'm going to go 90 degrees. It'll be angle right as opposed to angle left, azimuth, these quadrants by bearings, deflection left, deflection right, or use GONS, which is the European version of a gradient. I can use my little calculator to calculate some angles, and I can even measure an angle set by points. I'll pick, say, this point to this point. Okay, so, you can use those tools for you. But let's take this back to just simple 90. Leave a vertical angle of 0, horizontal distance, let's go 50 feet. All right, so if I create the point, you can also draw the line, or you can preview. So that's where it would go. So if I go, oops, I'm sorry, that's an azimuth. I wanted this to be angle right. So I can preview that. So there it is, 512 looking at 116, turning a side shot of 90, angle right, 50 feet. That's good. Here's my description, or I can choose code and take it out of a code library to set a symbol, et cetera, et cetera. If I just hit store, it's going to create that point. There it is. And it drew the line over to it. Now, I'm still sitting at 512 looking at 116, but you see up here, I've got that occupied point. I've got enter a sign, all those different things. So if I still sit at 512, but I want to change my backside to the midpoint of this line segment between 508 and 510. So I'm going to need to set up either an occupied point, or let's just do an inverse again. And now remember, I'm going from the backside to the occupied point. So I'm going to, now I don't have a point number. I need to find that midpoint, and that's not a single midpoint. I'm going to have to snap in between those 2 points. So I'm going to choose this button that says screen pick. Okay, pick a point. Well, I'm going to hold the shift key and right click so that I get, oh, actually I can't do it from here. So does it let me do it from here? No. All right. So here's a trick that I have to use it with. It's usually on that menu. Let me see if it's, I don't know why it's not. I'm going to come up to this gray area here, and I'm going to show my object snapping toolbar. It's not. Can't do it that way. Let's try it this way. Toolbar setup. Let's try it instead of Carlson. Let's use ICAD. Find the entity snaps. All right, so that's going to be these snaps. I don't usually do those, but There's one here called midpoint between 2 points. That's the one I was after. And I don't know why it's not on this menu. It normally would be. Well, the from means, but anyway. So now that I have this toolbar up, I can say, let's do an inverse from point. I'm going to click my screen. I'm going to say the midpoint between two other points. I'm going to say the midpoint from is 508 to 510. So you saw that little flash there. That's where it was. And it says PP up here because it's not a point number. It's a picked point. And then I'm going to go from there to 512. That's now my setup. And if I go to set a side shot there now of, I'm going to go, instead of angle right, I'm going to go angle left of 90 degrees. Let's go 100 feet. That, so I went from here to here, backside there. Angle left, which was pushing me up here. There's where I'm now setting. Let's do that point up there. Okay. So again, some of the tools that might be helpful for you as you're creating geometry in your drawing. And if those are helpful, to think of them that way and think of them in terms of points and drawing the lines, and whether you do it here or whether you do it with these commands in here, or whether you do these locate by, you know, intersecting, bearing distance, distance, compute resections. And there's a lot of different commands in here. And again, that create points from entities, set up your radial stakeouts, you know, all of these different tools that are available there. Okay, so I encourage you to explore them at least once to see what they do. And this parking layout business, all of this stuff, and the fact that you can, you know, actually dynamically create different layouts as you need. If that's something that suits you, I don't know if any of you guys have ever used something called Side Ops or Bentley. Now that Bentley owns it, it's called not Concept Station, but Open Site. I think it's called Open Site Designer. So that kind of technology is in there. That's sort of this live, responsive reaction to your design intent. And you'd set up the rules and set up different corner treatments and whatever makes sense for you there. And then as these things change, you can make those changes without having to redo a whole lot of extra work. Okay? Follows all right? Question at that point before we break for lunch? Anything? Everybody good? All righty. So it's now 12:16. We will get started at 1:16, so you'll have your full hour, and I'll see everybody back then. Okay. So hope everybody had a good lunch break. So we used a bit of some of the layout tools that we saw that we can use to work with our geometry as we're laying out things like building lots and such like that, parking lots, adjusting parcel areas and such. And what other tools would we have on our in our survey toolbox? And we can, if you look at these, we're not going to really go through a bunch of these, but if you have a surface model that you have created in your location that would sit into these points, then you can set those point elevations by draping them on the surface. There's a command there to by surface model. Or if you had 3D polylines that you wanted to elevate points up to based on their proximity to those polylines, you could do that as well. You have some of these other tools, for instance, a polyline to an RW5 file. We saw that yesterday when we took the parcel and read it and converted it into a RW5 file. And it basically stores the commands that you would use as if you were traversing through that polyline and set up, you know, your occupied point, your backside point, you turn the angle, go this distance over to the next point. It's sort of just an alternate way of looking at those polylines, and then you can of course adjust those as well. Now there's a couple of other little tools in there, some things in Kogo where we have, you know, we can best fit geometric figures to a cluster of points, for instance. Some different things for public land surveying. All of us are on the East Coast here, so there's not really much for us to deal with there, but you have those tools if you're ever working out there. These intersection points to compute points. For instance, if you do a distance intersect, let's excuse me, let's for instance do just to show how that works, say from 502 and 503, it's 91.96 feet between it. So if we want to establish a point that's 50 feet from 503 and 502, then we would do that as a distance intersect. And so we would say, pick a point or a point number. Let's just type 502. And the distance we want to use is 50. The next point is 503. And let's say, well, it doesn't have to be the same thing. Let's make it, let's see, less than 40. So let's make it 35. Actually, no, it's it needs to be more than, sorry about that. 502 and 50 feet. And then 503, let's say 65 feet. Okay, so now you notice there's two solutions there. It's either A or B, and you just need to pick nearest whichever one you want. So if you want this one, you'd pick over in this area. If you want this one, you'd pick in this area. And so now there it gives us, as if we're laying out a point, we can give it an elevation, give it a description, and there's our point selected. If we inverse those 2 points, you would see that's 50 feet there and it's 65 feet here. You could also do that graphically by simply drawing a circle at 502. It has a radius of 50 feet. And then we do another one at 503. It has a radius of 65 feet. And there you can see those same 2 points where it found it out when we did the intersecting command. Those tools are also available over here on this point. These are called temporary. I think it's called transparent point or selection command. So even if we didn't have that point there, so now I'm gonna, there we go. If we had, we didn't have any point located there, but if I wanted to start a point, or start a phone to draw a line. And I want that point to be, well, this time let's reverse it. I want to go, say 50 feet from 503 and 65 feet from 502. So it wants me to pick a point or a point number. I can go to my toolbar here. Let me drag this toolbar out so you can see which one I got here. And I want to do a particular distance intersect. So if I choose that, this is now pick the point. So 503. Point number, so 503. Say 50 feet from that one, and now 502. And 65 feet from that one. Again, find the solution. So we start there at number B, and then maybe we can go up here to that point as well. Okay, so I don't even really have to create a point there. I can. That's what happens on our COGO menu, where we located intersections or by angle, distance, et cetera, et cetera. Or we can use this toolbar called transparent point selection. So when it asks us for a point, we can choose any of those points and it's doing the same command. And that toolbar is your settings, toolbar setup. Make sure you're in Carlson and you scroll down to the transparent point selection commands, and that will bring that up. You can keep it handy. Okay. So those are some of our tools that we would use. Now let's move ahead to what, in my opinion, might be one of the greatest productivity enhancers in all of Survey, if you have things set up to where you can do this. And it's not necessarily if you don't have an optimum setup for being in the field, that if you don't have that situation, it's not necessarily true that you can't really use it, but you can always use it back in the office once you have things codified for yourself. The only thing that you might need to have happen is that the biggest thing is that the code that the field crews record be consistent. Like you want them to use MH for manhole and not MANHOLE, or if you want the fire hydrant to be FH instead of HYD, or whichever one you want, you need to enforce that for it to work consistently without having to change those point descriptions. But in any case, I'm going to close out of that and restart. I've got a little bit of a lag going on, so I'm going to see if this will clear that lag. So as that's coming up, let's go to, as we've done according to geometry. Oops. Let's see, what do I want to go to next? All right. Let's back up and talk about field to finish. And this will be in on page 67. So we're going to start a new drawing, set a new coordinate file, and then we're going to import some points. And we'll set that up to match our settings here. Okay. And then we'll see how we can use that to generate this drawing very quickly and very easily. Okay. So a couple of things. So I'm going to start a new drawing here. So next, choose new template. I'll start here. I'll set up my drawing to be in my folder. I'm going to call it F2F example. And set my scale to be, let's make it a 40 scale. Set symbols up to a 10th. And we'll say, okay. And we'll use a new coordinate file, import points from. I could go ahead and bring those in right here as part of this wizard, but we'll just go ahead and let it start out here in the middle, and we'll do that as a separate command instead of part of the wizard. Now, the process that we've got our coordinate file set up to F2F example. We've got a drawing file called F2F example. And we want to start using our field to finish. And here's hopefully a little exercise that will help you see some of those benefits. So when we still got this lag going, I think the next break I'll reset everything there. But anyway, so let's get excuse me, some points into our drawing and see what we can use these tools for. So if I go to my points menu and let's import points from a text or ASCII file. And this is going to come up and I can choose a particular format of a text file. If I have that already set up and I know it works correctly, I could probably use Carlson software and that would match, but let's just leave it user defined. So in case you ever have to do it, you can see how it works. The next thing is to select the file or even files, because you can have more than one. So I'm going to select the file and we're going to find this file called plat.txt. Plat.txt, and I can see that the format that I chose from the last time I ran the command was P, Y, X, Z, D, which means these are what those letters mean: the point name, the northing, the easting, the elevation, the description. And then if I had other fields, I could either skip certain fields or use a note, put the data into a note field. But these are the ones I need, and they are comma separated. And I can tell that by looking at this little preview area of that data file. Okay, so this shows you what is in that preview. Sometimes you'll see a file that might have a header line that tells you what this data represents, in which case you would come down here and you would tell it to skip however many header lines. That would be this part down here. So if you needed to skip 2 lines of header information, it would not read those first 2 lines. Well, we're going to say none because there is no header. We'll take in all the descriptions. We could limit that if we wanted, or we could tell it to skip the ones that start with a particular set of characters in our description. All kinds of filtering that you can do here. But we're going to draw the points. This is our process option. So I'm going to draw the points. Either don't draw them or draw based on draw locate points. So whatever's in your defaults for that. Or you can choose to bring them in with field to finish directly. So right now, let's leave it as draw locate points. And our point group to assign, we can make a group called imported points if we want. Okay, so I'm going to call that group imported. And store to a coordinate file, you can store them in this current file. You can prompt for another file, or you can choose another coordinate file based on the name of this input file. So we'll leave it set to current and we'll say okay. And it says it read in 54 points, and then it's going to draw, locate those 54 points, and then should zoom you to have those centered on the screen. And those are all going to be drawn with the current settings in your draw locate dialog or in your points default dialog. And you notice mine take a little bit of extra time. So what do we have here is a bunch of points brought in on whatever layer that they're going to be brought in on, using the point symbols and the attribute layout that is set by my point defaults. So if I switched to a different layout, a different symbol, put them on a different level or different layer, that would be how they would come up. Okay. So I've got some of these. I'm going to change my style so it's not quite so much ugly text. But if I look at these points, you can see the descriptions that are coded into these points when they were captured. And now I brought them into my coordinate file and had them draw. So I've got some points called shed, shed, shed. So it might be, you know, pretty straightforward that if I drew a line between 5 to 6 to 7, I can do that and make my shed. I've got a UP for, in this case, it does stand for utility pole. Over here, I've got an IPFL, and in this context, that stands for an iron pin and a fence line. I've got a fence line and a concrete monument, slash parentheses, 4-inch diameter, close parentheses. I've got an edge of pavement point, a manhole point, and then I've got some trees. I've got like 18D/oak, 24D/oak, so that's my diameter and my tree. And I come down below, I've got some things called building. I've got whatever this 12P is, that happens to be a 12-inch pine tree, but you notice it's in a slightly different form. And I come down here and I see a bunch of points that say PV, and that actually corresponds to pavement. So it's going to draw some kind of figure if I collect all those together. Now, this is the state at which a lot of us will get our points in from the field, you know, just like that. We don't necessarily know what this stuff means or which points get connected together. Those of you that are bringing points in from the field like this, are you still, and I presume, I would imagine, that you're still having the crews draw sketches in a field book so that you know which points are there, and they can, by their drawing, show you what they're bringing in. And that's part of what Field to Finish is going to help with, is to, based on those codes and the way that they survey those points while they're in the field, they can actually do all of that line work generation actually in the field and even see it on their data collectors so that they can tell whether or not they've missed something, perhaps, if they don't see it there on their data collector before they come into the field. But it really helps to eliminate some potential confusion so that if you're handing this off to somebody else, they're not stuck trying to guess what you meant by all that. You can sort of see, if I zoom in down here and I can see all these PV points, you know, it's not real evident on how that stuff connects together, but you'll see how that gets taken care of here in just a minute. Now, what we also have, excuse me, I'm going to minimize this for a minute and point to something in your switch over here so it responds a little better. If I take a look here for a minute, survey class and class materials. Now you have another folder here called F2F Quick Start Guide. Now, excuse me, that stands for Field to Finish Quick Start Guide. And there's a couple of things in there. I've got these PDF files. I've got one called LDT to Carlson Civil Migration Guide. That's a land desktop to Carlson. Probably not of a great deal of use unless you're coming from an old version of land desktop to where you can help bring that up. So you can disregard that. But we've got a couple of things here, an easy start and an advanced start. And this tells you, basically it'll step you through, and we're not going to go through this thing in depth. I'll leave this to your own exploration. But there's a series of files right here that are included in that folder that, and it tells you how to use them, how to set up the configuration so that it can use, you know, it's set to use those particular things. It's sort of optimized for them. And then as you go through, it explains all the different controls in your guide. And we'll go through that as part of our exercise here. And, you know, just with our own, but it will show you that basically here's the coordinate file processed through field to finish right as the points came in, and it actually, you know, creates this drawing, all the trees, all of the driveway edges, the building outlines, and it's actually in a full three-dimensional space. Don't know that they've got a picture of that in here, but you can see in different things that you can have it do as you work through those examples. See if it's, don't really see much there, but then, you know, so it tells you, explains a lot of these codes. So we're going to see a bunch of these as we work along through it. And I will also show the, let's take a real quick peek at this one. And this is more of an advanced step through, but uses the same files. So this will show you how to set things up to do, you know, rotated symbols, trees and pipes and all kinds of special codes that we just don't have time to do as part of the exercise of this 2-day survey class. But you can see, and it's creating curbs and offsets and things just basically on the fly. So it does two things. One is it keeps the field guys from having to do things like define, let's see, where was that curb? Here, for instance, instead of them having to go out and actually shoot the face of the curb and then the back of the curb and the top of the curb and all those kind of things, they can do it with one shot. And with their coding, and you can see right here as an example, it's an edge of pavement shot, and it's beginning this segment of edge of pavement, and it says offset horizontal 1/2 foot, so it's going to offset 6 inches this way, and offset vertical 1/2 foot, so it's going to make this back of curb being 6 inches over and 6 inches up. So that would be like a wedge curb along that line. And then once those offsets are created, it's going to come along to the next EP point. Those things are still there. So it's drawing lines between this EP point and this EP point, and it's offsetting horizontally 1/2 foot and vertically 1/2 foot, and creating 3D lines between that point and that point. And then it starts a curve rather, sorry. And it hits another point that's along that curve, but it saves or it serves a double purpose. It's also got an EOG, or edge of gravel point, because that's where the gravel drive hit in here. And it calls it 1 because we're going to start that, and we're going to come along here and get another edge of gravel. And if we didn't say 1 or 2, it would try to connect this point to that point, and that's not really what we want. We want to connect this point with that point, but we can wait and get that point later, and then come over here and say EP PT. So we're going to end the curve, so PC to PT, and then the points in between. Again, they're EP, but they're also edge of gravel. And then we stop, and then we can continue on and put an end on our EP feature once we reach the end. Then we're surveying back out here, and we get this other edge of gravel that's to connect here. We just put the 1 on it to match, and then it knows that's the line to draw. Same thing with EOG 2, okay? So that is the nature of what is happening that you can use field to finish to drive as you are working. And again, like I said, I'm going to leave those files and exercises, these data files, everything are in there. I'm going to leave that to your own exploration on your own time. So let's go back now and talk about this in a little bit simpler version so we can get a taste of it, what we're doing now. Okay, so we now are going to choose our field to finish, and we're going to change our settings, set some additional draw options, and the 3 set buttons down here on the right. We'll talk about what those will do for us. Okay, and we're going to use the code table that is in that, it's called F2F example.fld. Okay, that's the code table that we're going to be using for this. So when we draw field to finish, we have a bunch of points in our coordinate file. In fact, I'm just going to select these drawn points and erase them from the drawing. I don't have to do that, but I went ahead and did clear the decks. Now notice they are still in my coordinate file. If I list my points, there they are. Okay. So let's see what field to finish will do just on a first pass. I'm going to go to survey and choose draw field to finish. And I can choose the range of points to draw. I can tell it to draw just the points or any points and line work that those codes provide, and the symbols that those codes provide, any 3D faces that the code will create, or I can limit my field to finish drawing to a boundary that's pre-drawn or a certain distance, that kind of stuff. We'll just let it go here as well. But I want to make sure that I choose erase existing field to finish entities, because we're going to try this several times. And we're going to erase in range, which would be this range up here, or any other range that we choose. Now let's look at the additional draw options for a quick second. So as we are putting our points in, I'm going to have it create all of these different things in my point. I could not have them do that, but I will. I will also show my elevations, even if it's 0. I could prefix and suffix based on a code, and this is just the elevation settings we're talking about up here. And then locate the points on the real Z axis. That means place them at that elevation, not just down at 0 and label the elevation, but put them at that elevation. You can choose by those options. Same thing with line work, whether it goes on the real Z axis. Now, the reason I'm doing this by code is because let's say I've got points. Well, let's say take manholes, for instance, and if I want to draw sewer lines between manhole lids, but all I'm really shooting is the top of the manhole. I'm not popping the lids and getting the info. So I don't really know what the elevation is for those pipes. So I want those to stay as 2D lines. But my points actually have elevations, and I'm going to put them up at their proper elevation. But when it generates the line between those points, I'm going to have it read the code. And if the code tells it to create a 2D line, it will put it down at 0. If the code tells it to make a 3D line, then it will use the elevation of the points to create the line. So you can either turn it always on, always off, or by code. That's why I have it as by code. And then the next section is how it handles arc geometry when you're surveying your arcs. And you think about that like a curb return coming out of a parking lot. So you coming out of maybe an entrance and it's got a radius curve to join the other road that you're tying into. So you, excuse me, if you start that curved feature with a PC, telling it that you're going to start on curve, and then it will take any number of points after that PC until it reads the next point of that same code and it says PT to end the curved feature. And then it will create arcs from that. It's called sequential arcs. So it makes a series of connected arcs. So if you've got a really, really long curve, maybe the edge of a road or something, here's where it's going to start. And then you can go up and you need at least 3 points. You need to start and a point somewhere along the way, doesn't have to be the midpoint, and then the end point, the PT point. And it will fit an arc within that set of points. You also have a switch underneath there that says you can adjust the actual start and stop of the arc if you want to make the arc tangential within a certain tolerance. So I'm going to let it move by half a foot in case I were to miss actually finding the point where it would become a tangential arc. So you can have that on if you wish. Excuse me, it doesn't necessarily have to be, because arcs are not always necessarily constructed in a tangential fashion, but you could have it done that way if that's your intent. And then you've got point group creation based on whether the code tells it to make a group or whether it tells it, and this automatically by code means it's going to make a group with the same name as the actual code. Or you can say also make a group based on what the code definition says to make. So you have those two options, and then ignore the suffixes. That's like that EOG1 and EOG2. That's a suffix, the 1 and 2. This simply identifies them as separate features. So you wouldn't possibly want to do that. Creating point notes, we're not going to do any of those. You can keep your layers frozen. You can flip text for the twist screen in case you're rotated around and you want your text to always read correctly, right side up. Have it pause on the end defines, et cetera, et cetera. So those are the different ways that you can treat what happens. So we're going to set that up and leave it set to that as well. Now, what we have below is a series of 3 potential files, one of which is the code table. Those are the codes that are going to drive field to finish. So we need to set it to the one we want to use. Now, right now it's set to the one I used last called test.fld. It might show blank. So we're going to hit set, and we're going to choose from our folder. Now notice it put me back in my settings folder because that's where it normally tries to find it. But I'm going to now scroll down here and find my data sets and choose the one that I want to use. And that's this F2F example. So when I use that, that's going to be the set of codes I'm going to use. And then the coordinate file, now that's the same one that you set and we imported the points in, so that's already set. And then finally, the GIS table is a set, or it's a table, a file that has a set of GIS codes that can drive some additional data processing as part of this work. Now we're not using any of the GIS fields, so we don't need that particular table. We'll just leave it blank. If you have something set there, you could hit set and then just hit cancel to clear that out. So we'll say none. Okay. Now, the next thing that we would typically do is we just hit the OK button to have it draw if everything's set up correctly. So I'm going to do that, let it draw, and Yours is probably finished by now, but I'm going to wind up with this lag that's going on here in a minute. So. All right, so there it is. It came in and drew at least partially some of the stuff that I was intending to have it draw. And we're going to modify some of these codes and see what effect these have. I'm going to give me a thumbs up. Sorry about that. I have my son and two grandsons live here locally, and he called me. He doesn't usually call during the day. I was just afraid there was something going on. One of the grandsons is a little bit on the ill side right now, so just make sure that was okay. So anyway, we're good. All right. Let's see, I looked away. Zoe, I saw that you were back. How about Mark and Carl? Are you guys both still here? Thumbs up if you are. Wait a couple minutes. Okay. Just hang tight, Zoe. We'll be back. Turn the recording back on. Now, so Carl and Mark, as I was telling Zoe when I got back, sorry about that. Was my my son called in. I've got two of my grandkids are here locally, and my son's their dad. And I was afraid there was something going on with them. One of them is a little bit on the sick side, so just clearing that up. Turns out he just called. He didn't know I was teaching today, so there was no problem. It would get back. So apologies there. Anyway, so what we've done or what we've accomplished is this set of points now has come in and generated some additional line work and symbols, some of which you see. Like this symbol is just an X. This one is just a circle. But look at this point is a square, meaning that concrete monument. And if you double click point number 1, that's up in the upper right corner, you can see that on the general tab that it has a drawing description called 4-inch diameter. But remember when we first saw it, it said FLCM / 4-inch diameter, which means it's part of a fence line. It's also a concrete monument. So that part of the fence line means it's going to start drawing that fence. The concrete monument means it's going to draw that square symbol based on that, and the code set that. And then it's going to use the description of simply 4-inch diameter. Now, a 4-inch diameter square is not something that I've really ever experienced before. That would need to be a circle if it's 4 inches. But anyway, you get the idea. Okay. So that particular point actually served double duty. It served as part of a fence line. It also served as a monument. Now we look around some of these other ones and I see I've drawn some line work here between these points that say shed. And if I select that line, I see it's on a layer called building. Okay, and it is a particular color. It's actually specifically red and not just by layer. Same thing down here on my building. It's also on that layer called building. Okay, but that's how it generates that. I have here number 2, point number 2, which is a hub. It has no description in the drawing, but it has that symbol. So that's my traverse station there, and my mouse comes back over here. So it went from 2 to 21 to 48 were these points that I surveyed in, and it connected the lines for me because my code said to draw lines between those points. I I've got some other points over here. Notice this, 500.29. If I look at that, if I double click that text, it's not a point. It doesn't bring up the point editor. It says over here in my properties, that's just a piece of text. We'll look at that in a minute. If I see that symbol, now that's part of the point itself. And you see that I've got a coordinate file description that just says X, which is the code for a spot shot, but it has no description. And we'll see how that the code defines how it draws that point. Okay. Now I can use this, the fact that you see these lines, this line is drawn on a layer called traverse. This point is on a layer called points. We saw these other layers. So instead of everything being on the layer defined by draw locate points, this one here, the codes told it which layer to put this information on. Got another thing here where I start a curve and then stop a curve. You notice if I double click number 46, it's an edge of pavement, but the PC says start the curve. That's my point of curve. Come around here, and this point number 50 would be my PT. That's my stop curve, but I've got from point 46, 47, 49, and 50. So it's more than 3 points, but it takes those curves and creates an arc between 46 to 47 to 49, and then it continues that arc over to 50. Okay, so it will take, it needs at least those 3 points, and it does it as sequential points. Now, if I select that, you see all of these individual little segments, and I look in my properties and I see that that is in fact a 3D polyline because my code says to create 3D lines. And I think that's the only, yeah, it's the only thing I've got there. If I had made that a 2D polyline, that would be, you would see that's an actual arc. Now it's not an actual arc through here, but it simulates an arc. And it does so by replacing the curve with these individual straight line segments. And the number of segments that it's going to use is controlled by the setting. Turn to my settings menu, Carlson configure, general settings, and it's right here. When I remove arcs, that's when I'm taking a 2D arc and giving it elevation, which would be impossible to do and keep it an arc. If it changes elevations, then I need to substitute the original arc that is an arc in plan view with something that's going to approximate that arc in plan view, but it's going to go up and down and along the z-axis. And so I need to replace it by one of two methods, either this maximum offset or the chord length method. And that is how closely, let me exit this. I'm going to draw another arc here. Let's do a PC. See here, do a PC. Well, let's just do a 3-point arc. I'm going to go from 46, 47 to 49. Right. So that's now my arc, but if I zoom in close enough, I can see that this arc, which only has those 3 points, is not exactly on it down here, which is this series of little points, little segments. So that maximum offset is this amount of distance here. And that's the method I chose, was to use. And the other option was to use a chord length. So if I had chosen that and given it a distance, it would create these every so whatever that distance is. And again, that is in my Carlson configure general, this business right here. Okay, so I say only allow up to 2/100ths of deviation off that original arc. If I had said use cord length, it would make all of those cords exactly a 1/4 foot. Okay. Now you don't want to make that too tight, because if you use that 3D geometry to create your terrain models, then remember every one of those points is going to be the vertex of a triangle in that terrain model. Okay. So that's a little bit about what's going on with that in terms of the 3D geometry. But in any case, that's what happened. Now, I still have these PV points down here and nothing's gone on with those. And I've got a code that I need to modify to make that happen. So I've also got some trees up here. I want to change those to make that happen. You get an idea of how this is starting to work. So let's go back to survey, draw field to finish, and let's edit the codes now. And if we edit the codes, we can see a different set of codes and all of these different categories. It just helps you organize it. Or if I just go to, let's look at road features. I've got EP, that's my edge of pavement. I've got another code in here called mark. I'm not sure that it's even used in my commands, in my point set. I don't think it is. What else might I have? I've got bottom spot, I've got control hubs, IPS, MONs, CMPK, and I would look for that PV. Now I don't see PV in here anywhere. And if I go to my all, which means look at all of them together, and I'm going to click this code so it sorts them alphabetically. I'll scroll down and I see, well, indeed, I do not have a PV code. So I would need to make that code to make it automatically create some of that geometry. Now, there's a couple of ways to do some of this as well. In this setting down here on the left, I've got some reporting, and that was, if I just exit this, that's the same thing that this report codes and buttons does, but I can do it all from this edit codes. So I want to report, excuse me, my codes and points. So if I click that, I've got a list, a couple of different things I can do. I can report all the code definitions, okay, and only report the codes in my file that are used in this current coordinate file. And if I do that and say, okay, then the only codes that I have that are in my file is hub, CM, X, FL, BLD, shed, and EP. Okay. And you notice this line, these are the categories that those codes are in. Now, if I uncheck that box and say okay, you'll see the entire code library based on those different categories. Okay. Now, you can also report not just the code definitions, but if you use the points, the data points, you could show a list, a range. We'll take off 54 points. We'll say okay. And so here it says, I've got this code 12P, which is not defined, and it's 0.13. 18D is not defined, 11 and 20. Okay. Here's EP, which uses a code called EOP, edge of pavement, and it's 45, 46, 47, 49, 50, and 51. All right, so you get the idea there. But here's the one that we're really after, is to only report the undefined codes. And if I look at that, then I know these are the codes that I'm going to have to add to my code table. I've got 10 codes that I'll need to add to it. Now, if I do that, I could, print this or put this in my drawing, write them down, figure out which ones I need, or I can come right here and say code table by points. If I click that, then I'm going to say, I can give it a default symbol. I don't really care what that is. So if you want to append the current table or create a new one, well, I'm going to append the current table. Okay. And when I do that, here's all of those codes. Here's this 12P that had not been assigned yet. Now it goes into a category called trees. Oh, actually, did I put them all in trees? Yeah, I did. All right, let's see. Let me exit that, come back to it first. Go to exit, edit codes. Let's go to unassigned. That's what I should have done. Code table by points, append, and now, oh, it's still. Well, for whatever reason, it should go to that one there, but it didn't. So let's take my 12D, 18D, 24D, 8P. I know those all go in trees. Well, they're already in trees, okay. And then I've got my iron pen, which is going to go in set control, let's call it. LP is a light pole, so that's going to go in the same as my utility pole. And I'll move that to, excuse me, to utilities. Oh, actually manhole, I could have moved to utilities. So these are my trees, 12-inch pine, 18 diameter, 24 diameter, 8-inch pine, LP, that's my light pole. I thought I moved that already, I guess I missed it. Oak pine, PL, which is, I think, a point on line, and that would go on, we'll just put it in unassigned right now, which should be on the property line. PV, there's my pavement. I'm going to move that to my road features. So now these are trees. I still have PL for a point on line. I've got road features, and I've got some set control. So the ones that didn't do anything, like that manhole, it just drew by the point and kept its original code for the definition. Well, let's change those manhole codes. So I can look at utilities. I'm going to find this manhole, and I can see, I can tell the ones that haven't been edited generally because they don't have a name out here. This is just something that can help me remember what it is. Okay. This will be a light pole, for instance. Okay. Utility pole. So I'm just filling some things out. Now here, let's look at manhole as an example. So let's hit the edit button for that manhole code. And this is going to be what happens when you encounter this point called MH. And here's the code. That's the code that comes out of the field right there. So on this code, on the general tab, I can assign it to a particular category. Don't have to, but I will. I do want processing on. You can turn that off temporarily as you run this stuff so it doesn't interpret this, but I'll go ahead and leave it on. Here's its full name again, just for my use when I see the code. And this description is what, excuse me, what I want it to show up in the drawing. Now, I may, for instance, have this, maybe I know that that's a sanitary manhole, but I'm just going to code it in as MH. So that's where I'm going to change the actual description of the point once it gets drawn in the drawing. It doesn't change it in the CRD file, but it does when it puts it in the drawing. Okay. my main layer. Well, I'm going to not put that on a layer called MH. That's its default. I'm going to put it on a layer called V-node dash sanitary sewer. I don't think I have one called manhole. Oh, there it is. V-node dash manhole. Okay. And I'm going to leave this stuff set to its default. I'm going to say points only down there at the bottom. I will say locate on the real Z. And I'm going to go to my symbol tab. And I'm going to change that symbol. I'm going to pull this category down and choose inlets and manholes. And I'm going to scroll down till I find the one I want. Let's use this one as a sanitary manhole. And I'll say okay. I'll save that and I'll exit and I'll just hit OK to let it process and draw again. Now you'll see it erase everything and then it will reinterpret that MH code according to the rules we just gave it. Again, yours will probably finish up much quicker than mine did. All right, so now that created that as a manhole, drew the symbol and changed its description. If I double click that, I can see my CRD file still says just MH, but my description now says SAN MH. And, it'll go accordingly. Now, let's make another change to that. We'll just do the same one. Do this manhole. We'll go to the symbol, and instead of making it a 10th, let's make it 2/10. So it's bigger. And we're going to set a line type. Right now, it's set to by layer, and you can leave it at that. That's often what we'll do. But I'm going to set a line type up, and I'm going to scroll down here, and I'm going to find, there's a sanitary manhole there. By entity, which is not the one I want. I want the one that says CAN, I think. Let me actually really, because this would be storm. Let me see. Let's use this one. All right, so I'm going to do this one and my line type text scalar. I don't need that necessarily. Let's see, a dash C. We may need to adjust our line type scale when we're done. Let me see if I choose that where I was. My spacing, let's put the spacing at 0.08. And symbol is 0.04. Let's give that a try and see what happens there. Now, if all I've done here with this is I've assigned it a symbol, given it a size, and I've assigned it a line type, that would be the line that it would draw if, and you have to make sure back on the general tab, you change what happens right here. Right now, it's just going to draw the points only. But if I wanted to draw the points and I wanted to draw these lines, either 2D polyline or 3D polyline or both 3D and 2D. So if you're using the edge of pavement to generate your terrain model or curb lines to generate terrains and such like that, you might want to use both 2D and 3D. Use the 3D line work that it draws as break lines and then freeze that layer after you generate your surface and use the 2D line so that you can dimension things like arc radiuses and or radii, I guess is the proper term, that sort of stuff. All right. So we're telling it to draw the line. We don't know the invert elevation of that pipe, so we're just going to draw the lines. We're going to say, okay, now what this is going to do is it's going to look for other points in the drawing. I see that one there says, man, that's a manhole. And if I scroll down here, there's a manhole. And if I look down here, there's a manhole. So it's just going to connect the lines, and it's going to do them in the order that they were surveyed. So 52 to 53 to 54. And that is established in our code definition by see where we set. I guess it's when it draws, yeah, when it draws the line. So it would be on the line type tab. So the connection order right here is either sequential or it will draw to the nearest one of that code found. All right, so we're going to do it sequential. Now, this is where working with your field crews is important because they need to know that they need to draw them in order. Okay, they can't get this one, then go over here and get this one, then come back and get this one because it would draw the lines from here up to here, down to here. And you don't want that to happen. Now, there's ways to fix that. And that is if it comes in and they did them out of order and they're in these, point numbers, you just edit the point file and change the point numbers so that they're in a different order. And sometimes, let's say if it goes from say 52 to 53 to 54, but if you needed 54 to be 53, or if you needed to say add a couple of other points in here and change them to manhole, and you need to go from 52, then you would make these additional points something like 52A, 52B, 52C, then 53, then 54. So you can add something like that just as long as it would sort alphabetically in that order. Okay. So now that we've made that change, we'll save the table and exit and say okay and let it draw, and you'll see those changes. Again, sorry for the lag on mine. It has something to do with Zoom processing. Ooh, wow, that's huge. So if I look at that line, see that, so my LT scale is 20. So if I make it, that's what it said. I thought we'd have to change something. And that's a global LT scale that if I looked at drawing setup, that's this number right here. And there's a reason that it works sort of backwards, and it's an AutoCAD deficiency. If I set everything up here by trying to make it react to my mapping scale based on these numbers for defaults, this number, which is typically set to 0.1 because you want your line types, or maybe 1.1 to, let's just say 1, that means that every inch I want my line types to repeat. But the problem is it multiplies by this and comes out to here. So you sometimes have to set this one to 1 if you're using CAD based line definitions. The reason it's set up the way it is because way before AutoCAD was able to do line types very well, Carlson has always had the ability to do things like this line types and change the polyline. So you see all of these different lines, and you'll see them Well, let's look at it back here where you can see that there's something I wanted to show you. If I edit those codes again, go back to manhole. So utilities, manhole. And on the line type, when I choose this, these numbers right here. And you see this dash C, see that is a CAD defined line type. And if I come out there and select that line, it's actually only defined by its endpoints. Same as like a fence line that is a line, a gap with a X character and that kind of stuff. But you have different types. You have these ones that say continuous, continuous, and you have these ones that say entity, which means it's going to create that line by individual pieces. There'll be a drawn line, a space, then a symbol, then another drawn line, and they're individual pieces. And so Carlson was able to take anything you wanted to change and make a pattern, build it on the fly. And so that's a leftover from the old days before AutoCAD was really able to handle line type scaling very correctly. So that's still a holdup. So if you ever get something like that and you get a situation where that line that gets generated from that code is that giant size, then try setting that LT scale, the line type scale, and that'll fix that right up. Okay. So now I've got that represented in my drawing as a sewer pipe between manhole points. And if you didn't want that, you could either have it draw, erase it, or let it or go into the code table and tell it not to draw the line, set it to points only. Now let's take a look at our fence. Now here's an example of, you see that fence line is a letter X, and it's a line, a polyline, but each one of these letters are different letters. That's because of that same line type thing. So I will change that to use a properly patterned fence line type if I have it. You can also just leave it as by layer and assign it to the layer line type. And we're going to add some tree symbols from here. And let's see, what else might we want to do? These utility poles, we haven't defined those, and we haven't defined our pavement code yet. Okay, so off we go. Go back to survey, to field to finish. We're going to edit the codes. And let's look at a couple of things. Hub was already defined. It drew that little hexagon shape for the symbol, and it told it to connect the lines. And it goes on a layer called traverse. So we'll probably turn, maybe turn that one off, turn that layer off after we're ready to proceed. Our CM, concrete monument, we haven't, let's see, if we look at that, we see that it says don't use any description, CM, but why does it say 4-inch DIAM, you may ask? And the reason for that is, if I cancel this, controlled right here under my code table settings. I'm going to click that. And I'm going to make sure it says Carlson coding, split multiple codes. I'm going to say split them all, use multiple codes for line work endpoints, or line work only, or line work and symbols. And that's a case of like this multiple codes. This point has an IP and a CM. So it's using the IP code to create, or I'm sorry, the FL code for a fence line and the CM code for the monument. And so I'm going to leave that set to that. And I'm going to come down here and look at this button that says special codes. And when I look at that, I see, remember that description said FL space CM slash parentheses 4-inch DIAM close parentheses. So that slash is a trigger character that says right here, slash character means to append the description. So if my CM code said to use a description, it would have used that description just like we did up here for SAN NH, but it would also append whatever is after that slash character to that description. So I could have it say MON and then parentheses 4-inch DIAM. So a monument, 4-inch diameter monument, or CONC if you would like. So whatever is after that slash then would append that description. So there's all kinds of different ones here. We're not going to get a chance to go through all of them, but you can look at those guides, that advanced field to finish guide and the getting started, the quick start guide, and you can see how all of these things apply, plus the help system shows you what all these are as well. But here's the key that you have to make sure that you're using. When you tell it to begin a particular set of line work, so we use begin and end codes to start and stop. That's sort of like pin up or pin down and pin up. So, and they're not always necessarily required. Like a begin code would start one and it goes until it sees the next begin code. And so it stops at the previous one because it knows you're ending, and then it starts the next one. So you can get by without doing them, but it's just good practice to always start and stop. Same thing with PC and PT for our curves, the lines underneath that. Whether you start a curve and stop a curve, some people will just say PC and they'll rely on the next 2 points to define the curve. And then it goes back to being straight lines. So my preference is for people to make sure you use them, you know, where they are, even if they're not necessarily required. That way there's no question as to which one is what, okay? And you have certain things like CLO is just like drawing a polyline and you type close to close the figure. So you don't have to go back and resurvey the first point. You have rect code, so you can do a rectangle to close off a rectangle. And you'll see that down here, for instance, if we change, here's 5, 6, and 7, if we put an RECT on this number 7, it's going to construct that over here, these other two missing edges, to make a rectangular figure out of that. As your offset vertical, offset both, offset horizontal, offset left, JPN, join to point number. So sometimes you just want to join from one code over to another code that's not necessarily going to be drawing that. And we'll see that in a minute. We'll use a JPN to edit our points. Okay, so a lot of control and that we can use as we are gathering our data. That we add onto our codes. And then there's some handling as to how you want to tell it to use these suffixes. That's like that EOG1, EOG2. And if you put, you could have a practice to where you always use a suffix, but if you don't have the suffix on, to not draw the lines, only draw the points. So that's a way to do that. You can also, I think in the special codes, you can tell it to, you can suppress those things. Here you can tell it not to, you know, here's one called no surface. So you're going to make the point and actually put the point at that elevation, but you're going to flag the point as to be a non-surface point. So even if you select it as you're building a terrain model, it would not be used in calculating the terrain. For instance, if you shoot the top nut on a fire hydrant, well, that's not part of your terrain. That's sitting, 3 feet up off the ground. So you might want the actual elevation to be carried, but you tell it, don't make it a surface, as opposed to this code, no elevation, which means it reads the point, it reads its elevation, but when it stores it in the CRD file, it sets the elevation to 0. So you can do that if you'd like. All right. So there's a wealth of stuff there that you can start to get to use with. A lot of controls and filtering here as well. Tell it to stop line work at a gap in point numbers. Now here's one that's really helpful. I had a class with a fellow down in Houston, Texas, and they were out surveying along this long road. It was like 6 miles long and only, 30 feet wide. And so what they were surveying was culverts, the start and stop of these culverts under these driveways. And of course they had the edges of the road. And what they had, they weren't using the begin and end codes or suffix codes to tell it to create a new feature. And so if they went from the start of a culvert to the end of a culvert, and then they go down a road half a mile and they pick up another culvert, it still drew the line between the end of the last culvert and the start of the next culvert. Well, they're so far down the road lengthwise, but it's so close to being parallel to the edge of the pavement, it just made an unholy mess of all these lines that went, point to point to point, and they couldn't keep track of it all. So one of the first things they could do without actually going through and editing the points and adding start and stop codes, which is really what they should have done, then they could just tone this thing down to say, 500 feet. So if you shoot a point more than 500 feet long, or let's say more than, let's say 350 feet, different elevation, whatever numbers that you want to put in here, then you're going to tell it to automatically stop at that point and then start it over again with the next set of points that are within those particular ranges. Okay, so that's something that could be useful for you. I'm just going to leave them set to 1,000. All right. Here's another: interpolate no elevation points for 3D polylines. Remember the code that we use for no elevation. And if we had one and we're drawing 3D polylines, we could say interpolate its elevation as to where it fits along the 3D polyline that gets generated from the previous point that has an elevation up to the next point beyond that has an elevation. And then all the points in between, if you don't want their actual elevation, so you got these little ups and downs between the points, you could just say, well, interpolate any no elevation points along that 3D polyline, and it will set those points to those elevations. All right. So that's some of the special coding that we're going to be using. So let's set these ones up to finish and see the difference that we have. All right, so I've got this concrete monument. I'm going to edit that, and instead of no description, I'm going to say conc mon, and I'll put a space in there. That's fine to get that slash, because it's going to append on there. So that would be that. It's going to go on this layer called the control node. Thanks. map. A roadway, center line marker. Let's see, let's put it on the roadway marker. All right. And it should be okay for that. And there's only one in my file, so I don't need to do anything with it other than points. If I were connecting a bunch of monuments as my road edge or right-of-way edge, then I might draw a line for that. So that part's okay. My symbol again. I think I might make that a little bit bigger as a 10th. And I'll say okay to that. I wanted to verify something that I noticed here on my manhole. Yes, right here in my attribute size scalar, I'm going to make that 0.08 because I noticed it's a little bit bigger. Now, the fence line, was that in fences and walls? My FL is going to put no description. It's going to put no symbol, but it's going to use this line type. Well, I don't really care for that line type. So instead of that being entity-based, I'm going to look and see if I've got a fence. I don't see anything up here in the CAD defines. So I'm going to go past the entity defines and look for the continuous defines and see if I've got one. And there's these different fences. So I've got fence B and C, which is this one in the lower right. I've got this one, that one. So let's go back. We'll use this one. I need to set the gaps and the spacings and all of that. So the spacing is how far apart to make those symbols. So I'll leave it at an inch, and I'll set my symbol size down a little bit to 1/10 instead of 1/4. And I'll say okay. So I've got that one. Let's look at some of the trees. And I've got, if I look at that point, I've got an actual code that says 18D, and then it says oak. Well, the 18D code, if I select that, I want that to read 18-inch DIA diameter. And I'm going to put it on, just put it on the layer code. V dash node dash vegetation. Points only. Let's look at that symbol. I'm going to turn the symbol actually off, and we go back to this category points. Choose no symbol for that one, and I'll show you why, what we'll do in a minute. Because that's for my 18D. It's just going to put this there, and I would do the same thing for 24D. So that's going to be 24-inch DIA. Its layer would be V dash node dash VEGE. Its symbol would be none. And now 8P is not a double code, it's just by itself, so it's going to have a symbol. So that's going to be an 8-inch pine. And I'm going to give its symbol to be, say, this pine tree. And say my 8" is going to be my standard, and I'll plot it at 1/10 of an inch. So that'll be what I use for an 8" and say that. And I've got a 12" pine up here. So I edit that, and that's going to be a 12" pine layers v-node dash vegetation. I may need to fix it on the other one. I forgot if I did it or not. I'll change its symbol to be the same one I just used for that pine, but now if 1/10 was for an 1/8, I need to make this one 1/10½ to represent a 12". All right, so let's verify if I fixed the layer on this one. I did not. v-node dash vege. Okay. So, so far, so good. Now the oak, if I see a code called oak, I want to use, all right, that's a good symbol. For an oak tree, we can switch it to, let's use this one here, and let's make that one 0.24". v-node dash vege. And we'll say okay, and we will save that work for now. And now I want to look at these point like 11, 20, or 12 and see what that is coded as. So I'm going to go over here and choose this button on the right that says edit points. And if I look at point number 11, I see I have an 18D/OAK. Well, remember the slash was to simply append the description. So the 18D code says to draw the, to write out a description of 18" DIA, and then it would put OAK on the end of it. But OAK, because it has the slash, is treated only as a description. So if I wanted to fix this to where it's going to turn that into a code, I'm going to go to edit and want to find, I guess search rather, should be in the edit menu, but search I'm going to replace. And I want to replace /OAK with space OAK and replace them all. So it took care of those three. So now that will be treated as a code that follows. So I will save and I'll exit. And now when I save my code table, exit this and hit the OK button, you should see the change that we've just made, the changes that we've just made. Still haven't done our PV yet, our pavement code. We'll come back to those in a minute. Okay, so it's like my fence was rather huge. We'll fix that. I got the size wrong. And it looks like my oaks didn't get used. My 8" pine and my 12" pine were okay. I'm going to also change color for that layer. Now, you would have to figure out why this. So it replaced this, it used the 18D. It did not honor that OAK for whatever reason. So let's find out what that reason is. So let's edit those codes and let's find oak. The actual code itself is OAK. Processing is on. Raw description is not. So it's off. Go ahead and make that uppercase just to see it. Points only symbol, there it is. Inch. Okay, so there's no reason it shouldn't have done that. Let's see what my lines can get done correctly. But oak, so let's look at my code table settings for a minute. And I want to split multiple codes. I don't have anything that tells it to not process multiple codes. Line work, and symbols. Okay, so line work and symbols. Should finish. I forgot to change the fence while I was there. Let's see if this is going to work. There we go. So now you see that the tree symbol came up because I told it in that special code processing, instead of just line work and points, it had to be set to line work and symbols. So now it's 18-inch DIA, 18-inch diameter, draws the tree. So there's my description. Okay, so it did not put oak at the end of that. Oak. So when it sees that code, write that as a description. The reason it didn't is because it did not draw a separate or a duplicated point. So let's see. What about that one? If we say 18-inch diameter, so we're really just wanting those codes here. My 18D, that's going to be a pre-end. Let me think about that for a minute. Let's go ahead and put our mid-afternoon break in. And we'll come back and fix that and then wrap up some of the things we can do with this and then look at LotNet. Okay. So until we come back, any questions on this stuff at this point? Everybody good? Okay. Mark's good. Carl's good. Zoe's good. All righty. Well, I'll see everybody back at 3:05 and we'll pick up from there. All right. Now, as we were looking at these, real quick. Okay, now, as we're looking at these codes, we noticed that, or I noticed that the oak code put the symbol in, did not put in the description because it read the description from the 24D code, expanded it out, and then it used the following code behind that to simply pick up the symbol. So we have to come up with a different way of showing that if we want to have those descriptions appended onto that. And one of the things is, see, I could have it generate 2 points there. In fact, there actually are 2 points there, I think. No, it's just putting the actual block. Yes, and then this up here is the actual point. So it's an 18-inch D oak. The oak drives the symbol. But if, for instance, that point number 11, if I were to change this, let's, excuse me, let's take another look at a way to modify our field to finish as we're getting things set up. Now, by the way, if what we're going through right now looks like it is a whole lot of work for nothing, you know, because you could have edited this drawing to do what you needed it to do without a whole lot of effort, then that part is true when you're just poking at it and with this particular small file. However, what you're shooting for is the ability to take these codes and get them into a library so that everybody's using it, everybody knows how to bring this stuff in from the field, so that every job that comes in and you don't have to do edits on these code table at all once you have everything together. So right now we're just taking a set of unknown points and trying to figure out how we want to connect up that information. Okay, so let's, instead of using draw field to finish and edit codes, let's go back to our field to finish inspector and take a look at that as another tool. And so here I've got these individual codes. Now here's I'm looking for that 18D. That's this 18-inch diameter. So it says I have 2 instances. I've got point number 11, point number 20. Here's my code. Here's the instances, and each one of those will show you what point it is. And here's the description itself. Now, if we were to choose for point number 11, let's go to that code. So it's going to let me select the code, and let's look at the trees. There's 18D. If I don't want to use that code, but I want to use the code oak, and then I apply for that. See, what it's done is it's changed the description. And of course it didn't. It did it, updated it, but it never redrew it back. All right, well, let's not use that as a means of updating. So let's edit this. We'll go back to that edit points. Point number 11 was an 18D oak. Let's change That's 18D. If I use this instead of appending, let's prepend the code. Now, what happens with this is much like what we saw earlier with the /, except we're going to put this one in so 18, oops, this one. I forget, hold on. 20 was 18, 12 was 24. Okay, so 20 is 18-inch. Was it 20 or 24? 24. Save, exit. I'll look at my code table settings and special codes and make sure that the backslant is what I use to prefix. Looks like it is. Prefix the field code. Description. Or maybe I'll do something with that. We'll save, exit, and draw. This time I'm only going to draw 11 through 20. Let's try that. 11, 11, 12, 20. And let's draw 11 through 20. The code itself was oak. If I edit those points, 11, 12, and 20. Oak. Backslash is to prefix. Put spaces there. Now that should work. I'm thinking the I think trying to use the excuse me, trying to use the inch character in the data is what's making that fail. So, because it's telling it to limit the text with that character. So if I do that, now let's go back to the code table settings. Special codes. I want to, if I double back slant, is to prefix the field code description. So let's do a double back slant. and edit these to be that. And now 11, 12, 20. It's not. It's just doing all. Ah, ha, ha. See it right here. It says warning, skipping point attribute blocks for trees because that's disabled under the tree survey settings. All right. That's what happened with that. And that is actually here. So if I look at my trees, my 18D, that's a topo. 24D is a topo. That part's okay. That's a topo. Now it should be then under oak. And sure enough, right there it is. Because it's set for tree. And under my tree setup, it said to symbol options, draw the symbol, tree symbol for a drip radius to scale or by a size factor or by a trunk diameter. So there's all kinds of different things you can do for tree surveys. We won't have time to go through that, but they are in that advanced field to finish guide. So if I turn oak now from tree to just a regular topographic point, and pine would also be, we can leave that as a tree because we don't have any pine points. All right, we'll save, exit, 11, 12, 20. There we go. So now it says 18-inch diameter oak, 18-inch diameter oak, 24-inch diameter oak. Okay. And so they are labeled according to that control. So let's fix our fence line. That's 1 and 8 that we will fix. With a line type spacing scalar, inch, text scalar. Let's make that 0.04. And that's 1, 8. There we go. That's a little better. More like a fence. IPs, we could have it draw an iron pen. We can also draw those as we need. There's going to go down here to number 8 to 9 with a point on line. What happened to our EP? We look at our road features, our EPs are going to draw. Let's do 3D and 2D, and we will put a distinct I will put the main layer as V dash roadway. V dash road. Asphalt, or that should work. And our dual 3D, we're going to call BRKLN for brake line. And we will, excuse me, use our PV, and that's going to be on a pavement layer. That's going to be on V site. I'm going to have one. We'll just call it V site asphalt. And we'll use also 3D and 2D. And we'll turn our descriptions off. Turn our points to be nothing. Same thing for edge of pavement. I want the description off and the points also off. Now, I told you I would show you about the difference on these elevation points over here, 500.29. And that is this code called X. So it's going to be spot elevation that's going to go on this layer called spot, no descriptions, but the difference in what we're seeing with this one as opposed to drawing the points. All these others draw a point and it draws those attribute blocks, a point number, elevation, and description. These are going to be just a text attribute. And if I look at this button over here to draw that text attribute, to set it up correctly, I'm going to come over here, and the ones that I want to plot is going to be the elevation. And I can give it a description. In fact, I'm going to give it a 45-degree description. Okay. And it's going to plot at 1/10 of an inch. And let's see, somewhere right here, this checkbox right here, the elevation label decimal is going to go right where the point is. So you may have seen spot elevations on maps done that way. So I'll do that there. It's going to rotate it at 45 degrees and use the decimal. So I'll turn the symbol for the point off. Then that would be the actual spot elevation. Just draw them all. It didn't catch for me. There. So there they've been turned. The decimal is the actual spot elevation. Now that may or may not be to your liking. You might want to use, instead of that, you might, excuse me, you want to actually draw the tick mark for the spot. For instance, you would, excuse me, potentially This is what I should have two. I do. My brake lines are going to be magenta. Pavements I'll make yellow. And excuse me, so I've got actually two items being drawn right here. Remember that one that we did the 3D, but we also did the 2D. So if I hold the shift key and push up here a little bit, change that. Call it to be. This is on a layer called V Road Asphalt, and this is a layer called brake lines. Mouse to come back here. So, so what's happening is all of these things are being drawn in 3D, and everything down below is kept as 2D. So what I can do with that is when I select this, you see that that is still an arc, and that's an arc. So when I label this, if I choose to label it with my annotate, I would actually be able to read the radius of that and use that to document that line. But if I want to try to label that radius, it's not a radius, it's not an arc, it's just a bunch of those sequential segments, because that's what it has to do. Now, what we will do with those 3D lines now is to use them to help create our terrain model. And we're going to also freeze and thaw a couple of things, and we'll do a little bit more cleanup here. Now, if you take this, this point, for instance, or this line that you shot 3 corners of a shed, you didn't shoot the back one out here, and that's okay. If I want to turn that into that shed, that completed shed, if I have 2 segments, or even 3, if I had them, if I had 3, all I have to do is select it and choose close in my setting over here. But if I choose, it's on my survey menu, a command called 4-sided building. And if I pick that, then it turns that into a 4-sided building. It takes the, and that is a 3D line that went from here to here, and then it just continued that slope there, continued this slope there until it met in the middle. So if I look at that in 3D, I don't know that you're going to see a whole lot of differentiation. No, it's not really, but it actually, this line controls that slope, this line controls that slope until they would meet at that common point. Okay. Now, I've got another one here that's going to work the similar fashion. If I say survey, 4-sided building, and I choose, and I've only got one edge, it's going to ask me back here, well, how far off do you want that to go? You know, 15 feet, 25 feet. Well, let's take the default of 15 feet. And now it wants to know which side to go to. If I'll click over here, so now it's done the same thing. It just took that line, that original line, and offset it. Now that the original happened to be a 2D polyline, but it would just simply offset it over to that spot and then connect the endpoints together. So those are some things that you can do. I'm going to go ahead and erase them. We're going to make a couple more modifications. And let's look down here at a PV. Remember, I turned the descriptions off, but, and I turned the point symbols off, but there's the point itself. Now, if I look at this point number 27, it starts here and it goes around to point number 28, 29, to 30. And I see it goes 27, 28, 29, 30, 31, 32, 33, 34, all the way back around to point number 44, which is right there. Now, if I wanted that to be a complete closed polyline, what could I do with this polyline? And notice I've got actually two lines. I've got a 3D polyline on V-site asphalt, and I've got this, and they're probably the same layer. Yep, V-site asphalt. So I want to put this one on brake line, and I'll change the code to address that as well. But what would I do if I wanted to make that a closed figure? You can simply select it and choose closed, yes or no. But what else could you have done in field to finish? Remember this code. Let's go back to my field to finish inspector. We will find point number 44. That is a PV code. It's PV codes are found in all of these instances, but on point number 44, I'm going to change its code from PV to, I'm going to add that special code close to it, and I'm going to apply. Say okay. And so you see how it closed back to that point. So I'm going to also, let's go back to my field to finish. We'll edit the PV. Dual 3D layer to be KLM. 2D. It's all very good now. So I've changed that. Now let's figure out what else we could do, say up here. So if I have 5, 6, and 7, I'm going to go back to, I'm going to edit my points. I'm going to change point number 7 to be not just shed, but shed RECT. I'll say that. And exit. Make sure that is the right code. Special codes. Rectangle is, yep, RECT. Okay, so I've got some things I can change there. Save, exit. Let's draw them all. And sorry about this lag. All right, so there. This point being shed with a special code of RECT, still only put the description of shed over here because that's what the code said to do, but it created that rectangle. Now there's a number of things that we could do down here if we're surveying, say, a building. And if I look at this building and see it's drawing a 2D line, well, if I wanted to, let's say I've got I see that point And it's really going to be it's going to be a structure out over here. But maybe I'm sitting up here and I can't see past this pine tree to get the actual corner of the house. So if I look at that and I want to see that it is, that's 20 feet long right now. But maybe that house is going to be, say, 18 to 19. It goes as far as it goes, but it really was out to like 30 feet instead of 20 feet. And then we had some changes that I couldn't get to. Maybe there's brush in the way or whatever. And all I'm really interested in doing is showing the footprint. I don't necessarily need the elevations of that, although technically I would, to help control my contouring. So anyway, here's what we can do with that. If I go to my points, and I'm going to actually, let's see, let's go to one last trip, draw field to finish. I'm going to edit my codes and I'm going to edit my points. And then point number 19 is that second building point. Well, I'm going to say I start with building, which was my starting point. In fact, I'm going to put a BEG here for good proper technique. Same thing I would do up here to BEG. Rectangle closes it. So here's my building begin. And I'm going to say, from there, I'm going to say, what am I going to say? I'm going to need to look it up, actually. Sorry. So if I want to look at that code, and it's a special code, and it is an offset. There's an offset horizontal, offset vertical. Offset left, offset both. Distance. It might be in this distance. I have to turn it. Let me see. Begin. Close. Rectangle. Offsets. Offset left. Looking for an extension, but no, it's jog. That's what I'm looking for. So if I jog, yeah, jog, then OH or an O. Right, so jog, extend by distance. Find this. Search jog. There's another nice little addition that they've added, by the way. If you see this, you can hit a point and just measure the distances and code that into the point. Like your point would be like BC ramp 321 uses the bottom of the curb and then ramp to put this in 3 for the width, 2 for the, or 3 for the width, 2 for the depth, and 1 for the side taper. So it's got a foot of side taper. It goes back 2 feet and it's 3 feet across. So it's a nice way to really pick up a lot of geometry. But I'm trying to find the old jog code. By the way, this is an excellent little help section on field to finish. I would suggest you maybe print that out and bind it and study it, as well as those 2 guides that are included in your downloads. Let's seem to. Let me turn that on. See if I can find it that way. But these special characters, let's find it now from here. That's not that. There we go, job. Jog, here we go. So that allows for additional points inserted into the line at a perpendicular or straight offsets. Only offsets should follow the jog. So positive numbers indicate a jog to the right, negative numbers indicate a jog to the left. Alternately, R and L. Okay. And finally, S is a straight. So yes, that's what so right here's the example that we want to use to create that. So we'll use a jog code. All right, so we're going to edit that point, and that was point number 19. So if I said that's a building, and then I add a jog of S for straight. So let's go. Sorry, I accidentally muted myself. All right, so we're going to say jog, go straight for 5 feet and then turn right 10. Sorry, keep hitting it. All right, so we're going to go, so we're out to 25. We're going to go 10 feet, 10 feet, so we're 35. We're now at 15 feet. So then we're going to turn right 35, I think, or 35, and then finally close. Right. Let's see what this does for us. Well, let's just simply do 18, 19. There we go. So that drew that entire house for us by these additional codes. So the last one was a building. I couldn't quite get to the corner, but I measured it up. It's 5 more feet. So I jogged straight for 5 feet. I turned right for 10, left for 10, right for 15, right for 35, and then close back where it's supposed to be. Okay. So that will create that. My shed will be created there. I've got probably my IPs I would create. We'll go back to all here. So I'm going to take my IPs. And let's put that on. We'll just leave the description there as an iron pin. We'll set the symbol to be, let's choose these circles with the wipeouts in them. And I'm going to actually go to the line type and I'm going to choose a property line if I can find one. Probably that. I don't think there's one. Oh, there's an OHP for it. What is, oh, there it is. So my spacing, I want to make 1.5 inches and set it to 6. Got my symbol, so points, 2D polyline, which would also draw the points as well. So that will connect my IPs. All right. Now the edge of pavement over here, which is going to draw that edge of the road, which will help become a break line for us. Let's add something else that it can do. In the, right now it says to draw 3D and 2D line types. If I'm in my line type choice where I could assign a line type, right now it's just going to be by layer, and that's fine. But down here where it says template, I want to create a template. I'll show you how crazily stupid this can actually get. I'm going to set this to be, make sure I'm in my folder, which I am, and I'm going to call this one EOP template. Specify an existing file. Okay, I guess I have to edit it first, rather. New EOP TPL. So no problem. Now, I'm going to define what happens when I collect that point. I'm going to uncheck this right side, same as left. And I'm going to say, I'm going to pretend I'm shooting the face of curb or the gutter line, the flow line of the gutter. So I'm going to add I'm going to go out to the left now. So I'm going to go up a vertical distance of 1/2 foot. I'm going to go a horizontal distance of 0.05, just 1/2 of a tenth. So nearly vertical, because I cannot have a vertical surface in a terrain model. And I'm going to call that my TC top of curb. So there's that part. I'm going to add another one that is going to be vertical, same height, so no difference And I'm gonna make that horizontal a 1/2 foot away, and I'm gonna call that my back of curb. So there's now the back of curb. Now I'm gonna go over here on the right, and I'm gonna add a gutter. So that's going to be a slope of a positive, say 4% slope for a distance of 2 feet. That's going to be the actual edge of pavement because I'm coming off the concrete. There's my gutter. That's going to be the edge of pavement. Now, to continue this even further, I'm going to add by slope a 2% slope, a distance of 12 feet. That's going to be my center line. And I'm going to add by minus 2%, 12 feet. And this is my that was EP and okay, so I'll just call it EP. Oops, all right, so EP, let's call it right. And while we're there, we might as well add at a minus 4%, 2 feet, FCR for face of curb right. And we'll add a vertical difference of 0.5 vertically, horizontally 0.05. And that's top of curb right. And then finally, we'll add a vertical difference of 0, a distance of, to work here, 0.5. And this will be my back of curb right. Okay, so I now have a 3-dimensional structure that's going to be created just by simply surveying this point right here. Now, would you actually do that? No, because obviously you're, that road's not going to be built exactly consistently based on that elevation. However, if you're doing things like in a brand new parking lot, and you're just doing an as-built, you're just going to fly through and get those gutter shots, or maybe you're going to set it up and get the back of curb, and you just want it to generate those extra lines. You don't really care about how consistent it is because it's all new construction. You're going to assume it's all fairly well taken care of. So that part we'll take care of that. We want to actually change as well. Change this X spot elevation to actually use a little tick, and also in this text attribute, I'm going to uncheck that decimal and a point, and I want the elevation rotated at 45 degrees from, now the position is going to be the, I think, upper right. That's what I want. I think we'll see. And I think that's all I really need. So, okay, save, exit, draw them all. Oh, actually, no. I need to do the light pole and utility poles. I've got utility poles 3 to 4 to 22. It's a light pole, so 3 to 4 Yeah, 3 to 4 to 17. It's utility pole. Yep. So UP. If I edit that, I'm going to use this symbol. And you could rotate the symbol to the line forward. And let's set that a little bit bigger, 0.15. Then my line type, I want to call that OHP for overhead power. I'm going to come down here and find in my continuous an OHP. And my spacing, 1.75. And my symbol size, or the size of the text, 0.08. Let's make it 06. All right, so let's see. Now we're going to draw 2D poly as well. So now we'll save that. And finally, I do have a light pole that's out here separate that will draw over, coming as a drop off of one of those other poles. So if I look at point number 22, it's a light pole. So that LP, let's just change its symbol. To be this light pole here. No lines, or actually points on light. Right. So that's now that go. Now I would have put those on the different layers and all that. I'm going to take the time for that right now. But so I'm also going to, because that's a power pole there and the main utility line is running through here, we're going to draw a line once we get all this drawn over to connect it. But I'm also going to say that that has a power connector over to this building. So point number 18. So I'm going to say at 22, I'll edit this point 22. And I'm going to join to point number JPN. Sorry, JPN 18. So if I want to, while I'm out in the field, I'm shooting this point. It's a light pole. I'll put in an LP, but I also want to say, well, go ahead and draw a line over the point number 18. So I just joined to point number 18. And that will temporarily supersede that. I don't have to put it in the code. And then you'll see what happens. Well, I see my line style didn't work out like I wanted on this one. We'll fix that. My property line was nice. Here's my spot elevations, which should probably be a little closer down there. We'll fix that. Here's my line from my join to point number. And so for right now, let's take this one code, which was the utility pole. Notice the symbol rotates itself to the line forward. So this one is rotated that way. Once I get to this next symbol, it rotates the pole around so that it's now relative to that location. Okay, it also rotates the points themselves. Okay, so that's okay. We'll leave it at that. So now let's fix that one. So that was UP. I'm going to take the description off. I'm going to need that. I'll go to my line type and fix this. Oh, not 0.3, 1.75. I don't know why I didn't set that when I did it the last time. The text would be 0.06. Say okay, save, exit. Oops, let's go back to that X and set its attribute. It's going to be at the upper right with really, I just want, if I put it on the right side, and the fact that it's rotated, that should fix that. That, save, exit, go. All right. Wasn't quite exactly what I would need, but I can tweak that and put in some offsets. Now, here's my overhead power line. So that's more what I was looking for. I've got a light pole out here with a power drop back to the building. I've got my traverse stations all set up over here. So look down here what I've got. Got all of this stuff as 2Ds and 3D lines. In fact, they probably, do I have? Yeah, I've got them both. And in fact, if I want to see what that looks like in my 3D viewer, this is all of the three-dimensional information that got built. And if I zoom this down here, you can see that's actually built that entire curb structure. Now you see the point that was shot was right here. All of these points, and then it hits this point up here where it starts an arc, and then it starts building around. But as it built that one point and connected to the next one, it went up and built that line, went over, built that line, then it went out and built that line, climbed to the center, did that line, came back down. You see what it did is it built that entire road structure in 3 dimensions. So we're going to use that to generate our frame model. Now, instead of fixing the code right now, I'm just going to take a quick pass at those spots. I've got them selected. I'm going to move them. I'm just going to pick them up and move them like that little bit right there. There we go. So that'll fix that. I've got my Get my points. There's that one and that one. I'm going to draw, bring them to the front. Okay. Same thing to do with that one. Draw them to the front. All right. So got some things that I've generated automatically. And if my code table is set up and my people are following what they need to follow correctly, then I'm in good shape. I've got all this stuff drawn. So let's see what else we can do with that. You know, again, if everything comes in and I don't have to make the edits, it's just a simple matter. Draw field to finish, boom, I'm done. So, but what I want to do next is to freeze some layers here. So I'm going to freeze off my point numbers, my elevations, and I'll freeze my traverse layer. And that, oops, do I need that one? Yeah, so this point, if I can get to it. I think Zoom is complaining on me here. Oh, yeah. I'm going to stop the share for a minute and then come back to it to see if I can reset that. It's causing a problem. Keeps triggered something. This is not anything that ever really happens other than with Zoom. So let me see if I can't turn that off and get this to respond here. All right, I'll get this. Okay, let's see if that'll fix it. Now, got what I was contemplating here. Oh, I'm going to check this point. That's a line on layer traverse. That's on layer PMTS. So I don't want to freeze out. I want to select these and make sure they go on that layer called traverse. Now, I'll freeze traverse. And I will freeze my elevations and point numbers. Now, everything that I've surveyed, spot elevations, corners for property lines, for fences, the sanitary manhole, I've still need to go through and fix this point. Which was flow line CM slash 4-inch DIM. So fence line and then concrete monuments up. And still should have put that 4-inch DIM in there. Well, I'm going to take up the time to fine tune this, but I'm going to take this little attribute on this point and just select the little insertion point and drag it off the symbol a little bit. And you can set the codes up. You can set the codes up to do that. Let's see, just there we go, regen. So you can set the codes up to make sure that it doesn't step on the symbols and do all that kind of stuff. So, but let's carry on this last little bit of what we have and see what we can do with it. If we have this, I'm going to simply draw a layer here. I'm going to call it topo. Let's call it BDY topo. Okay. Close. I'm going to use that as my boundary. I've got points here that will be red. I've got geometry that will be red. I'm going to triangulate and contour off my surface menu, in which case I will save the file called site topo, and I will use inclusion and exclusion areas. I'll ignore zeros. I will densify my break lines every 5 feet's fine. Draw my contours, e.g. minor, e.g. major, draw index 1s and 5s, label my contours, say every 300 feet. No filters, say okay. Select my inclusion, select my exclusions, and then select my data, now you're gonna see some arrows come up here. That's where these cross, so I'll zoom to and zoom in there and I see, oh, okay, I see what's happened is that this driveway structure actually crosses over my roadway structure, which was this set of curbs. So what I need to do there to fix that is, of course, beyond that is the fact that I would not normally have a driveway that has to jump down over a curb. So I need to interrupt this curb. Now, if I were surveying that out in the field, I would go ahead and get this curb point. And then as I'm walking along, I would make sure that I still had, dang on it, this thing is still. Should fail. Okay, great. That's all lovely. See if I can get it to save. All right, bear with me one more time. I've got to actually set this whole shebang. And restart that portion. Another reason I use the emulation, so if I ever have to restart Windows, which happens more often than not, I'm not interrupting my Zoom session. So anyway, here it comes back in just a moment. All right. Let's let that settle down and we'll go from there. So anyway, I was simply trying to create the terrain model and what my plan to have done there. And I'm not going to take the time because we're almost at the end of your day. But I was going to break those 3D lines that got created so that the driveway tapered down into the actual road that got surveyed. And you would see then the contours generate as they go across that file and such. So it's the last visit on that. Again, I won't fix it. You'll see the little disjointedness to it when it comes up, but you can see the end result. And if I freeze, Oh, let's figure that out. This one had to be. This one is Rex. Okay. No. So if I take a look at this in my 3D viewer and then add a surface, you can see down here, there's my little excluded areas. That house is sitting up there on top of this hill. Now it's probably, not, well, I mean, who knows? It's probably on a flat pad, but you see the idea. So you've got some points, like here's a point where that utility pole was. Looks like it's down, sort of depressed in a hole. Got some edits that we can do. For instance, if I take this point out, oh, actually, I need to. Well, it does not fare well. We need to probably shut the whole thing down and back up. And again, you should not, and I dare say, does any of you guys having anything slowing down on yours? I'm going to say probably not. This is all coming because of me hosting Zoom at the same time, and I'm getting some graphic card issues. Anyway, try that. One last. Oh, yeah, see, it's not even. Not even responding to that. All right. So in any case, now. So here's, if you follow these steps in the manual on your own, you can see this was a case where this is how that actually would generate. So we took these poles out for their elevation, and you can see the contours. Instead of being squared off back here in the back, we made sure that this line was not used for it. But there's your road edges. See the contours coming across the crown of the road, and your driveway down here. And there's a case where we filled in those closed figures with a hatch. That's another thing you can do with field to finish. And so you can manage to come up with a pretty complete job in just a very little time. Now, here's another example of using it for field to finish, but again, not really doing it for your finished production work, but to actually control the work when you're building terrain models. So if you have, there we go. So if I had a bunch of points that came into my work and they're here, they're just called ground shot. And then I've got a bunch of points out here in these side areas, some that say 17, some that say 18. I don't have any idea what they are. If I just grab all of those points and say, build me a terrain model, then this is what it's going to turn into. I've seen surveyors turn that in. Say, oh, here's your terrain model. Well, it's been a while since I've seen surveyors do that. Most surveyors are smart enough. In fact, they're smarter than most of the engineers in terms of how to build this. They can look at it and say, well, you know, that's a nice clean ditch that goes around this outside edge. But I've got a problem because I've got points that are creating triangles across that ditch they shouldn't be. So I need to make break lines. Well, I look at this and I can tell by inspection that, oh, hey, the 17s look like they're the top of the bank and the 18s look like they're the bottom of the bank. So I can make a little 2-code table that says connect all the 17s, connect all the 18s, and then process it with field to finish. And so it will do that, and it will draw and connect those lines up and as 3D lines. And then when I process it, you can see, and I didn't change the data one iota. All I did was generate those 3D lines and use them as break lines. And so now I've got this nice ditch all the way around the edges out there, all the way around the edges down here, and this little plateaued area up here. So you can see the difference that it makes in your work to use the break lines. And that was something that helped me do this with these codes, because I've got ground shot 17 and 18. 17s at the top of the bank, 18s at the bottom of the bank. And I just went through field to finish and said, hey, connect up the 17s, connect up the 18s. I inspected it to make sure there was, nothing obviously wrong with it. And they all worked because they were done in the right order. Rebuilt the terrain model and had a much more refined surface model than I did just by taking a bunch of points. Okay. So that is the advantage of field to finish with that. Now, being right at the end of your day here, I want to introduce you a little bit to ServNet and show you where you can do this on your own. You've got some steps here. Talks about ServNet processing. We did some things earlier this morning on some lot layouts and some controls. Well, this will actually take certain layouts, if I get to them. That talked about some LotNet processing, but then starting over here on page 75 is your exercise with LotNet processing. So just go through the steps. You get those toolbars and you'll see here's an example of, there was a closed polyline figure that represented the boundary. There were these polylines that represented the center line of the streets. That was all we had. We defined a bunch of rules, like how big to make the lots, whether or not to put building footprints, what our setbacks were, how to label it, how to generate the lots, and it goes through and actually creates the entire subdivision. And I went over here and plotted off my line and curve tables, because you can see in here, obviously, I've got like C17, C4, C5 over here. I'm sorry, it's a little fuzzy because it's just a blown up part of the PDF. So it will completely automate all of this. And just like we did with the lot manager, where we changed that little sliding side and such like that, you've got tools in that toolbar, which would be these tools right here, where you can do a sliding, you can modify these lot lines. And there's your sliding side, there's your hinged side, and then you can have it not only process that, but then let's say you processed a bunch, you've made some edits and changed a bunch of things around, but now you want to go back and renumber the lots. Well, you can tell it, hey, start here, work your way around it, and it will renumber them sequentially and put them all together into a lot table and work yourself through it. Now, when you work through this exercise on your own, follow these steps. It should be okay. I don't think you'll have much of an issue, but you could come into a situation where you have to make sure that the center line actually goes over and touches that boundary. You need to make sure that the numbers you use are not too big. So if I made this cul-de-sac with too large a radius, you know, it wouldn't, and then I had a rule that said I need a minimum sideline on my lot to be, say, 65 feet, then it, you know, it'll blow it up sometimes. So you have to sort of, you know, be sort of somewhat designed. You know that these are going to be your roads where they are within our subdivision. You've got this space between these two center lines has to be of the proper depth. I mean, it won't kill it, but you know, you want to be able to get two lots deep between those two and 2 lots deep between these two here, so that it can find the best way to create the resulting subdivision like this. And then once that's done, you've got it all in that entire LotNet manager where you can just modify this, you can relabel, regenerate all of the subdivision labels, and you know, put building footprints. You can even have it elevate these lines in 3D based on road profiles so that your houses all get set up to be a certain distance above the back of curb. If that's, you know, part of what you're trying to do, it will, in a case like this building pad, it will rotate it so that it stays within the setbacks. And here's a case where you've got 2 lots, but it couldn't fit a building pad because of the setbacks. So that's either, you know, a trip to the zoning board to request a variance, or you take that dividing line out and make it a single lot. You know, there's all kinds of ways that you might deal with that. So beyond all of that, let's see, that's what I was wondering. Carlson configure. So I think that might have fixed that issue. But in any case, we won't flog that dead horse. It is the end of your day. You'll get a chance to relax in a little bit. Now, what I wanted to talk to you about further here is not only to look at that exercise in the book, but also look at some of these other options that you may have available to you. And that's, if you look at the help system and go to the Carlson manual. If you go to that Carlson manual and go to the table of contents, turn that on, and down at the bottom, you see this section called tutorials. And there are a number of different step by step routines in here that work with the sample data that's delivered when you install Carlson. A lot of these are really old, but they're pretty good. still. So this field to finish for faster drafting, as an example, it shows you right step by step by step how to do this. And it actually, even this particular one uses the exact same set of coordinate points that we've been using. And they may, approach the definition of the codes a little differently than I did, but you can see what they do and how to make it all work. And they take that all the way through, rotating the plat, putting it in a title block, annotating the property lines. Let's see what else, building a legend, throwing the north arrow on, so it's pretty thorough treatment of it with a pretty simple example. Those other two things that I showed you when, let's see. Part of your downloaded data in this field to finish quick start guide is the advanced and the easy start. So this easy start, for instance, and again, it shows you, steps you through what all those controls do, and will generate this whole thing. And it actually creates everything that you see here, all of these road edges, the building edges, everything is at proper elevation. And it actually makes a pretty impressive little site for you to take a look at. And it is real data. That's real data from a real project. Okay. So same thing with the advanced, where you get some of the more advanced treatments like rotation of symbols, tree surveys, again, all those double codings, templates, etc. That you got a bit of a smattering of those things here with this little example, but this will really dive deep. Okay, so that's available to you. It may take you a while to get comfortable with them all. And then finally, if you go from that, let's see, there's other things. There's making it flat. Yeah, they're using the same. They're using the same data for making it flat. This is if you were doing it without field to finish. So it steps you through all those particular steps. And then they show you in this field to finish for faster drafting, they take that same set of data and generate that as a drawn plat. Now, so that's something in tutorials. There's also ServNet, which is that least squares, a network, multi-network adjustment, how to set up the general rules, how to review the data. I think that this is probably a little dated in the interface. It's not, I didn't notice it. Yeah, see, it's got this old interface. It's a lot easier with the new interface. And you'll see that it's not going to hold anything back, but that shows you how to do that part. Okay, so all of those things are available as part of the help system. Now, beyond that, you've got these online movies, which are going to take you to Carlson Software's YouTube channel, and you can create, you can go into these different categories, videos, go to their home, look at playlists, look at them all. You can find them by, let's see, there's machine control, precision 3D, power tools. The power tools is pretty nice. They're little short videos that show you how to do just a single task. Very bing, bang, boom, done. Serve PC, that's sort of like Serve CE, but runs on the computer. Anyway, you can find your way around. Let's see if there should be a field to finish. There's a survey overview. Here's field to finish. Look at the playlist. Looks like it's got one adding custom attributes to field to finish. Okay, so find and take advantage of all of these different, here's some land surveying, for instance. There's importing point clouds, point clouds, GIS attributes and field to finish, GIS to field to finish beyond the basics. That's a really good one. Configurations, coordinate files, field to finish, how to create a table, and it's just 15 minutes long. Okay, here's that deed correlation that we did yesterday. Doing some drawing cleanups. Okay, full subdivision using LotNet in 18 minutes. It will show you how to do all those different things. So they're really good to show you step by step, and you can stop and save and do all those from me. But it's linked directly from your help system on this online training movies. It takes you right to Carlson's YouTube page. Okay. Now, the other thing to remember, and I promise I'm almost done to be able to let you go. When you get, if you ever get to, you get stuck on something, you need some help on anything else, my email address is in your manual. You've also got it because I've sent you links to these sessions, but use that. You stay in touch, and my phone number is in there. You're more than welcome to, to call. If I am in class or busy or can't take the call, just leave a voicemail. I'll get back to you. You can leave an email. I'll get back to you. But that is yours as a point of access, from there on out, because you were part of the class. That's not something that goes away. If it's something that, say, hey, I need help, and you show me how to do this, and it's going to take a week, then, we talk about, well, maybe you need either some additional training, or then maybe that's something that you might want to hire us as a consultant on a project. I've got a client doing that right now. He does railroad design. He's putting a spur rail in right next to the Ohio River up here in Pittsburgh, and he's got a lot of really critical areas that he has to sort of force his geometry into. So those are all things that I can do, and he really wants somebody looking over his shoulder as he does this work. And again, I'm not a programmer. I'm not a software salesman. I actually do this, and I do it for a living. I have my own practice. So all of those things are available to you. But if they're simple things, even if it's something we didn't go over in class, if it's a simple answer, an hour or two, heck, that's freebie kind of stuff. So, I'll let you know if it's too much, and we can talk about something else, but it very rarely is. I think I've got 2 clients that use me in that case, and I've been doing this for about 15 years now for them. So use that, use the email, use the phone number, stay in touch, let me know how things are going. And now what comes after this is I'm going to be sending everybody certificates for your continuing education. Any of you who are registered and need to track continuing education hours, you will get those sent to you. And we also keep permanent records of all of that. So if you're ever audited or whatever, we can back up your attendance. We can document that you were here for that. We have your certificates as well. So with all of that, I will ask if there's any particular questions that you need to get taken care of today, or if everybody's good, we'll call it good and go from there. Okay, so it's good.
Yeah, I'm good. Thank you very much, Ken.
All right, Mark, you guys take care. Carl, looks like you're good. Everybody's good. I will, like I said, I'll send you these certificates. I'll also send you a link for the